one. So then I didn't get the net profit, so I use the gross profit for the appropriation account, and then I use. But I don't know if the current account would be right because I don't think it has anything to do with it.
Right. So remember, hey, that's Domino's, what?
Yeah.
Wow.
We literally
30 minutes or less. I don't know why nobody liked that bodybuilding.
Like if you
drugs, and plastic surgery. You could do
no, but
more.
it was just kind of like one shot to it. Since it's kind of too much to talk about.
I agree.
I didn't spice the social norms. Like not it, like why you have to comfort the social norms. You have to be beautiful, or you're slave to be beautiful.
I honestly put something like some people would have been encouraged to do it, like for the beauty pageants, like some people's parents would have done it and then they would have been more encouraged to do it. Yeah.
I didn't have it, so that's
Because they feature let's get this
you can get
right.
like anorexia or whatever.
Because then catch it.
I didn't get it.
Let's get this bread.
Well, no, I'll catch it, but before, yeah.
Part 3.
Can I take one?
This one. I saw
Yeah,
you
go
see. I saw you see there.
No, I'm good. I'm gonna die.
This one here?
Yeah.
Yeah. So this see there and I realized that was for these two. Then they're asking for bearing of R from P.
From P? Right. So, to find that out, well, you can find the whole thing, probably using like Sinus or something,
Okay.
and then add it to the 132.
So you're not good.
I have tons.
Look. That's how much. He just like picked up people's bags.
Because this is from ordering food or.
We didn't even start any of these yet. Wait, alright. We don't do this for yeah, but we still have to do these through our sunny temperature. My last one. Yeah, you are feeling it.
I don't see. So we're doing MCQs now.
Now we're doing the other theory and the MCQs are for home. But the answers on the Q file.
The next tune is Sphinx. Do you multiply before adding?
Yeah.
What is bombast again?
Brackets, order, multiplication, division, addition, subtraction.
Okay. So addition and subtraction go last.
Yeah.
These are the last things to happen unless they're in a bracket.
Understand the bracket.
So whatever's in a bracket is worth first, and then you go out from it.
I see.
Yeah, tomorrow, evening, right? Yeah, tomorrow's Wednesday. Yeah, you know, no, Omari.
Chris, I see how y'all do simultaneous yesterday and completing a square.
Yeah.
I missed that, brother.
It's only live.
Oh.
Yeah, but the problem was the live was sticking, so when you check it out, it mightn't be the best quality. But you will see at least a couple examples work. Craig, if you want anything, feel free, yeah? We're on YouTube.
What do you think is coming
Right,
tomorrow?
that pizza, that recipe, correct? Yeah.
Pretty bomb and stuff, right?
Yeah.
So like say they have 3 in brackets, 2 close brackets, 3 power of like 2. Which one do you work first?
Order.
Inside brackets.
You
Power.
say power.
So this 3 multiplied by, let's say, 2 squared, 2 squared, then by 3. Right?
I'm afraid of number deviation.
Standard deviation. You
Oh.
don't have to calculate it. You don't have to calculate it. So is it pepperoni and pineapple here too, eh? And it's hot.
And when I say I got fancy butters.
Yeah, real hot. I don't leave the album for now. I should leave
Where is
it.
Domino's?
You know, it's not like
Minus
others.
Oh, right there, that's why they came so long.
It was a robbery this morning at Starlight. My man got arrested downtown.
What's going on?
I don't know, but I saw it on TT News before news on Instagram.
That counts as relatives. Shut up, crime is funny, so pretty.
You can run highway after it.
You see, why did that person there get that woman there get shoot up in Chicago?
That was
Sharon, like,
Who's that?
Sharon.
They want to kill our whole family. They killed his brother already too.
No, okay, because
No, I think kidnapped him.
He got killed.
Sharon's brother killed him.
That's not about just no way.
They wanted 2 million ransom for Sharon brother, but they only paid 300,000 and they killed him.
They leave him in the drain, he's
Yeah,
hiding the airborne.
Nah, but actually, I love this country. Alright. Yeah, cause so you tell me before the thing came for the partnership. Yeah. So I didn't do the income statement. That was the 8 marks right there. Cause I just physically couldn't. I just didn't know what to do. I looked at it for a good 10 minutes. I just really couldn't. So that was the only thing I left out. But I did the appropriation with the gross profit value. And I worked everything properly as in, and then was this next thing, the current account. So would the current account still be wrong?
You would have not. You wouldn't have the correct figures, but if you have the correct item on the correct side,
Yeah.
you should still get some marks.
Because it's just interest on drawings, and then if it's negative, it'll go down on the debit side. But if it's not, if it's normal, it'll go down on the credit side. Right?
On the credit side, you put like the salary.
Income,
Interest on capital.
interest on capital,
Yeah.
Share
profit. So now I have formatted good. It's just I just don't have right figures. But having wrong figures, no one take.
Yeah, I think I might have a few wrong figures, but I think I have the format.
And then the ratio question was really nice. You know what the people look like or no? Very nice people, boy. Very nice people. I don't like how they start with that balance sheet though.
How come?
I don't know, it just shocked me. Because I just opened it, I was like, no balance sheet. Other than that, anything else? That T accounts too was weird, but it was manageable, like it was easy, but it was still weird. And then that multiple choice, oh my god. It was easy.
Just thinking that everybody said it was easy and then everybody just feels it. Madly done.
I see down to like 5 minutes
Alright guys, here how we're gonna proceed, right? So we're already running late and backlogging our topic. So I'm gonna go through some stuff on the board, topic by topic, right? But I wanna start with the vectors, then we'll do matrices, and then circle geometry. Alright? I know that's kind of backwards as to how I initially planned it, but I feel like I wanna do it that way.
So you can make it a little bit.
Yes. I'm telling 0 viewers starting in 2 minutes. Yeah, no problem.
Yes, you can.
My pleasure. Well, I see you again after today. So,
Yes, you should let us know about those econ.
the econ I might be able to give you guys 2 double sessions the 2 days before.
That will be how
Econ is a Wednesday.
Oh, you talking about paper 2 too?
Yeah.
Alright.
When is it from paper 2?
23rd, no.
No, that's
Yeah, nah, the 29th of May on a Wednesday.
You're feeling really boy. When you finish?
Time, Chris. Yeah.
And you're gonna do anything for the POVC or not?
I might only be able to do one double session for that
On the Wednesday?
the day before.
Alright.
Because I have to cater for my Form 6s. Hello. Believe we are back in business. Back in business? Yeah, back in business. Alright, folks. Alright, so we did some bearings and apparently I have bearings, I don't know. So somebody had asked about vectors. So what I want to do I do pure math classes? Unfortunately, at this point in time, Nafisa, I don't, but I am looking to start it within the next academic year. So next year, September. If you want pure math, I have a friend. Oh, good afternoon, Mr. or Miss Srinivas. Right, sorry, I was talking to Nafisa. If you want someone who can do quality tuition and that, I have a very good friend of mine. You didn't get any? Sorry. Sorry, guys. That's Kyra. Yeah, we're organizing some vectors first, then matrices. Or maybe I just didn't put on that spot. Alright, hold on. Yeah, you have it? You have it or you don't have it? Look, I have. Vector. Alright guys, so we starting back. Hope everybody had a little snack and some water. Alright, so what do you need, John? Anyone is anyone? Anything? You can take the black, you can take the blue. This blue is actually a black one. Try that one. Alright. So so the format now is because we kind of we're behind time quite a bit and we don't have too much time again. I'm just gonna go through some examples on the board, give you guys a couple to try, and then we're gonna move like that, right? So we have, like I said, an hour and about 40 minutes. That's 100 minutes. Divided by 3, that's about half an hour each. So I'm gonna do one example and I kind of walk through a couple with your briskly. Right, so we're hoping to get to the vectors, matrices, and a couple of circle geometry. Everything? We're hoping to, right? Okay. Okay, so we're starting with the Jan 2019 question, which is on the board here. Right, so it's the first question in your vectors handout. Alright. And of course, everything else you guys can carry home and try, and you all can check it on the Q file. Alright. If your Q file not working, message me, I'll send you a link. Alright, and you can access all them solutions. Yo. No, he's asking about that one. If the one that we did was 25th, that's probably 2014, 2013. Yeah. Okay, so first thing to do is to read the question, right? A lot of times we don't read properly, right? Even earlier I made a mistake in one of the questions with Akron and Compton or something. I put the distance in the wrong place, right? So you see, not reading properly affects me too. Okay, OABC is a parallelogram. OABC, where we just have O and A down here. But all right, stop it. Go back. All right. X is the midpoint of AB, and Y is the midpoint of BC. The vector OA is equal to R. The vector OC is equal to S. Complete the diagram below to represent all the information given above. Alright. Good afternoon, Ashley. How are you? Hope you're fine. Alright. So OABC. So as we know, the lettering goes in alphabetical order. So B should be on the top right hand side. Now if you all know the question and want to go ahead and do it, please feel free. I'm explaining for those who need some explanation, right? And C therefore would be on the bottom right hand side. Let me see if I can get a letter formed a little better. Alright, that could work. Now OA starts from O and goes to A. So if we had to put an arrow on that line, it would be an arrow pointing upwards from O to A. Are we okay with that?
Yeah.
Alright. And they're telling us that OA is given as vector R. Alright, right? So we can't really write in bold, so you could underscore your vectors to show that they are vectors, right? That's one way to do it. OC. Now OC starts from O and goes to C. So the arrow on that line will be pointing to the right. Let me see if I get a little, not as, okay, that'll work. It's not art class. Alright, and OC is given as vector S, shorthand. Alright. Okay, so is everybody okay with that?
Yeah.
Yeah? Alright, anybody have any questions?
No.
Huh? Which year is this? Jan 2019 actually. Jan 2019, it's at the, sorry. It's at the bottom here, Jan 2019. Okay. Now, let's just see what else it told us. Oh, sorry, we're not finished yet because it said all the information above. We didn't put in X and we didn't put in Y. Now, X is the what? X is the midpoint. Midpoint means how far along the line? Halfway. So I have the arrow on that halfway point, boy. Okay, I think I'm gonna have to shift that arrow down a little bit. Just, I should have left it. For those watching on the live, this is the bane of my existence. Trying to write properly. X is AB. Ooh, there you go. Put it back. So X is the midpoint of AB. So that's around here, right?
Yeah.
X. BC. So around there? Alright, cool. I don't know why I thought it was the midpoint of OA. Alright. Okay, are we okay with that now?
Yeah.
Alright. Now, once again, midpoint implies how far along the line? Halfway. Alright, now that's a very important, it's a very simple item but important nonetheless. Given that OX plus OY is equal to K multiplied by R plus S, where K is a constant, using a vector method, find the value of K, sorry. Okay, so OX plus OY is equal to K, some constant multiplied by R plus S. And they want a vector method to find the value of K. Alright, so let's just write that out again. So OX goes from O to X. Do we have a vector that goes along that blue line I just drew? No, we don't. Yeah, R is this vector here, not so? Which, by the way, would also be CB. Why is that? Correct. They are opposite sides of a parallelogram, and opposite sides of a parallelogram are equal and parallel. Right? So BC is also vector R.
Okay, sure.
Yeah?
Do I go O8 to then E to X?
That is correct. Right? So to go from O to X, we have to travel along the lines that we have. The shortest distance of travel from O to X is O to A, as we have that by that blue line there, and then, as Jono said, from A to X. Now, AX lies on which larger line? AB, correct. How far along AB is point X?
Midpoint.
It's the midpoint and it's halfway along it, right? So, here, we could say that to get from O to X, we have to go from O to A first, and then we have to go from A to X. Now, O to A is, as we know, is R, not so?
Yeah.
Erase, please. Thank you very much. Right. And AX, we said, is half of the larger vector AB, not so?
Yeah.
Now, AB is parallel and opposite to what other side of this parallelogram? OC. Which means, therefore, that the vector that represents AB is also going to be S. Correct. Therefore, AX equals Nafisa. Very good. Right, so we have R plus a half of S. HARF, half. Nice. Now, that is OX. Let's repeat that process for O. I line real straight, boy. Anyhow, sorry. I marvel at these simple things, trust me. Because when I write, I'm looking like a shaker in the cold. Straight lines and lines that don't have any curvature to them amaze me. Alright, now to go from O to Y, what's the shortest path to travel from O to Y? OC. And then CY. That's correct. Oh, looking like I have GC. OC plus CY. Now that Y is that CY lies on what larger vector? CB, right? No, you're correct. And it lies halfway along the line, not so? Now OC is S, and we have to add that half of CB. Hey, my initials, boy. Right? And that vector CB is what given by R, not so? So that's a half R. Very good, Nafisa.
She did it?
Yeah, she on the ball, you know. Now, we are given that this exists, OX plus OY. So we have OX plus OY. So we're going to take R plus a half of S and add it to S plus a half of R. And we can group together the like items, R and a half R, S plus a half S. What's 1 plus, so 1 is understood in front of that R, not so?
Yeah.
What is 1 plus a half?
1.5.
1.5, very good. So that could be expressed as 3 over 2, not so?
Yeah.
So that's 3 over 2R, and saying S plus a half S could be what? 3 over 2S. Now, look at how they want it to look. They have a constant outside of a bracket of R plus S. So how do we remove the 3 over 2? Factorization, by dividing, that's correct, right? R plus S. Now does this resemble what they told us? K multiplied by R plus S?
Yeah.
And now just looking at it, what is the value of K?
3 over 2.
3 over 2. So therefore, K is equal to 3 over 2.
So you would want to keep it. You would want to keep it in 1.5.
You can. 3 over 2 and 1.5 are equivalent. So in my opinion, it makes no difference which one you use. Unless I said it had to be in the form, let's say A over B or B over A, which was definitely a proper fraction. But in that case, it still wouldn't be proper because it would be 3 over 2. K is 3 over 2. Very good, Nafisa. Alright, lovely. Alright, and that was actually the entire vectors question for 2019. Jan. Right, so they kind of, that was hard? Alright, cool.
I wouldn't do all of this.
I would tell you that.
Yeah.
Well, it's just 3 marks. So you'll probably get like a mark here, a mark here, and then a mark down here.
All 1 mark.
Yeah, a mark each. Wow. Alright, okay. So scrolling on. So you guys can turn the page, those who are here. And we're going to look at the May 2018. So this is from last year's paper.
So I guess I told you about this, right?
Yeah, you had come about this recently. That's correct. Alright, so for those on the live, I'm sorry if it's a little blurry. That's the copy that I got. Right, so if you guys have a hard copy, you can take a look. If you have a soft copy, you can take a look. Alright, I'm just going to scroll a little bit more. Sorry, I need to zoom out because it's looking a little too... Oh, what is going on? Behave thyself. Alright. Okay, so the first thing to do is to read the question. But you're ready to go on it or not yet?
Hold on. What do you go on?
Ready?
So.
Alright, hold on. Let's read it, right? So the diagram below, not on the scale, shows a quadrilateral ABCD in which AB is M, which is here. DC is 3M, which is here. Now, what can we say about the lines AB and DC? They are parallel. Very good. And there's another relationship between them. Which one is bigger? DC. How many times bigger than AB is DC?
3.
Aha, there you go. Simple and straightforward, right? Oh, you're answering down here already. Okay, alright. If you want, okay, complete the statement below on the geometric properties of the following vectors. So AB and DC are parallel.
See, in an exam, I put B is 3 times.
Right. And when they have those 2 vertical strokes, right? So I have to go physics class, so I will watch a video when I'm finished. Alright, Nafisa, have a good class. Thanks for joining. Right, so when they have the vector between these 2 vertical strokes here, they're asking about the magnitude or size of the vector. Right, so what was the size of vector AB?
1.
M. Well, they give it as M, sorry. Right, and then this one here is CD. So if you want to get M from 3M, you have to find a third of it, not so?
Yeah.
Right, so AB is equal to 1/3, or if you wanted to write anything, you can write out 1/3. 1/3 times CD. Yeah.
So why is it just not 3 times?
Yes, it would be minus. Why would it be minus? Because it's going in the opposite direction. Look, AB goes which way, right or left? AB goes to the right. But CD is going to the left. Good pickup, good pickup.
He's smart because it's how DC is going to the right.
Yeah,
but
DC
they
is
want
going this way.
CD, and CD is in next door.
Correct. CD is going from C to D.
Yeah. He's smart.
guys told me that.
Yeah, bro. And I tell that, and I bypass it here too. So you see how when you're rushing, right? When you're rushing, because I'm rushing right now because I want to cover all the material. When you're rushing, you can make mistakes, right? Yeah, well, you get like a halfway mark because you identify the correct scalar per se. Well, at least the absolute value. All right. Okay, next, express BC in terms of M and N. So BC goes from where to where? Where does it start? It starts at B and goes to C. So it's going here. Do we have a vector for that line? No. So we have to travel along the lines where we have vectors. So we have to go from B to A to D, and then D to C. All right.
M minus N minus 3M.
No, not minus.
Right. So that's BA plus AD plus DC. So BA, if you notice, right, BA, minus M, because correct, AB goes to the right, and that's positive M. So if you're going in the opposite direction, you have to use the inverse of the vector, which is minus M. That's equal to minus M
Plus N plus 3N.
Correct. So minus M, right? Going from A to D, that's just N, and then going from D to C is 3M. Not so? Now, if you rearrange and group the like terms together, you can get 3M minus M plus N, and 3M minus M is 2M plus N.
Whoa.
Mm-hmm.
How to factorize it?
Factor, we're factorizing.
No factorizing, sorry.
Well, you could try.
Simplify.
Yeah.
No, because he put the first line.
Oh, yeah. I just went straight up.
You say you found negatives, Brian? Okay. BC in terms of M and N. Alright, so we just did that. Express BC. So once again, to go from B to C, alright, means you want to go from point B to point C. But we have no vector along that line. We have vectors along the other three lines. So we have to travel along those three lines to get from B to C. So we have to go from B to A, and from A to D, and then from D to C. Alright, going from B to A is the inverse of AB, so that's why it's minus M. Alright, okay, anybody have any questions on that item? No? Alright, cool, we're going again. If we scroll down, it says L is the midpoint of CD. Find BL in terms of M and N. So L is the midpoint of CD. So let me scroll back up.
Hold on, so let me see if I know that. Minus M plus N plus.
So this is L here, right? As the midpoint of CD. And they want us to find BL. So we are, let me put that one in green.
I did.
Right? So we are required to find a vector for BL. So we have to go from B to L. Right? So how could we go from there to there? We have two ways we could go. We could go from B to C and then C to L, or what's the alternative? B to A, A to D, and then D to L. Which way y'all wanna go? To the left or to the right? To the left, to the left. Alright, cool. Right, so going from B to L, you'd start up by going from B to A. Correct, and then from A to D, and then from D to L. Correct, so Johnny, I said, what is BA again? BA is minus M plus N. Now, DL is half of DC.
Oh wait, so it'll be 1.5 M.
Correct, so we have minus M plus N plus
1.5.
a half of 3M. Right, so minus M plus N plus 3 over 2M. And now we could rearrange and group together the like terms. So we have 3 over 2M minus M plus M. So 3 over 2 is 1.5, right?
Yeah.
What's 1.5 M minus 1M?
1 over 2M.
Right, 1.5 minus 1 is a half, not so? So you have a half M minus N. Sorry, plus N.
Yeah.
Sorry, and I have M on top of all that. My bad. My apologies to those on the live too. Right? So once again, to get from one point to the next, you simply have to follow the lines, right? You have to move along the lines using the vectors you have. Alright. And that was the entire 2018 question. Does anybody have any questions on the 2018 question, any part of it? No? Alright, cool. Let's
Do
do.
you advise that I learn all the matrix transformation?
I would say give it a shot, learn at least the rotations.
Rotation.
The reflections are relatively easy. The rotations are the one that,
Or like 1, 0, 0, 1.
yeah, that kind of stuff. If you could learn them, fine. If you can't learn them, don't worry. At this stage, like I said, try to consolidate what you know. Trying to add more on top of what you know right now could have a negative effect on what you do know. I'm not saying don't try. If you try, cool. If you're not trying, yeah. But you have the sheet, right?
Yeah.
Okay, you could. Yeah, you have to really work with those for a while before this time. Use them over and over. The matrices. Or once again, you have to look at the behavior of the x and y.
Rotation.
Yeah.
No, like you have to remember the exact matrices, like 0, -1, -1, 0.
Oh.
Alright guys, let's turn one time. And we're gonna try Jan 2018. I'm gonna see if we could finish Jan 2018 and May 2017 before we switch to matrices. Because that would carry us to the half an hour. Sorry? Jan 2018, yeah. Alright, so it's just the next question, right? So those on the live, I hope everything going okay. Good. Delma, how you going, boy? Delma, Andre. Alright. Thanks for joining. Hope you get some value from today's live. I think they did. Alright, some of them asking for the AdMaths live. The AdMaths live's coming, guys. Right, we just want to deal with maths first, and then we'll talk about the AdMaths lives after. But probably going to do Thursday and Friday. I don't think I can do Saturday or Sunday because I have things to do. Monday for sure, because you know the AdMaths is on Tuesday. So the Tuesday. Yeah. You can let people know. Why does it keep scrolling back up to the question? I don't understand. I don't understand, man. I do it. No. I do it.
All these questions there.
Yeah.
So they just rebring in.
Yeah.
Vectors right here.
Right. Given vectors. So this is, by the way, this is Jan 2018. If anybody in live following, right? Jan 2018. Given the vectors OP. So now they're giving us in column vector format. So remember, you can work with these like that too. And don't forget your unit vector format. Right. That's with the i's and the j's. So if you wanted to see that, this would be 3i plus 4j. No, they didn't ask you to do this. I'm just illustrating. Just to kind of remind you guys that you can write these in with the i's and the j's as well.
And the eyes.
The i's are the horizontal components, the ones on top. The j's are the vertical components, the ones below. Alright? Determine the vector OQ. Alright, now what vectors we have? We have OP, PQ, and RS.
Yeah.
To go from, so okay, what's the only vector we have with O right now? OP. Well, you had a star there, not so? And what's the only vector we have with Q? PQ. So OP plus PQ. Now this here is a very important point. When you're trying to combine vectors, usually the endpoint of one vector, which in this case was the endpoint of the first vector, P, is the start point of the second vector, Q.
Yeah.
Right? So, well, OP and then PQ. Is it Denisha? Am I saying that correctly? Right? Yes, you're correct. OP plus PQ. Alright, so all we have to do is take OP and add PQ. And we simply combine the horizontal components with each other and the vertical components, right? So 3 plus minus 1 is 3 minus 1. Alright, so what we're going to get? We're gonna 2, 6.
You can reduce it then.
No, you can't reduce. You could pull out you could factorize almost like with a scalar, but you can't reduce it.
Oh, so you have to leave it as 2, 6.
That's correct.
Okay.
Hey, terrain, right? Terrain. Hello, how are you? Glad to see you again. Thanks for joining. Right, now, as Antonio was correctly observing, he was saying, well, you could reduce 2, 6. Now, don't reduce it. It's not a fraction, right? But you could factorize with a scalar and get 1, 3. And what do we notice about that?
Equal to RS, so...
Well, no, it's not equal to RS. It's 2 times RS,
Oh, yeah.
right?
Alright,
And that,
Because you divide by 2 to get the 1.
you factorize, right? Now, check it. Show that OQ is parallel to RS, giving a reason for your answer. Good pronunciation. All right, thanks very much. Yeah, but my last name is Bagarati, so I know how it's when people don't pronounce your last name correctly or any name correctly.
How come people mistake Bagarati?
Bajarati, Bagariati, all kind of thing. Anyhow.
Today's example goes, I don't know how to pronounce your name. Literally, Brian. Like that's the simple.
Is it like Breen? I don't know.
Like, oh gosh, make an attempt now.
I know.
5 letter words.
Alright, good night. Viresh, good night. Jonathan, Ramesh, good evening. Alright, we're going again. Sorry guys, I keep getting sidetracked. Right, now here, show that OQ is parallel to RS, giving a reason for your answer.
Okay.
Right, now, let me hear you.
One, I was going to say that RS is a downside of OQ.
That's it.
P.
Right.
Q is
Mhm.
a scalar of 2 to RS.
Right, so you are correct, but you have to say right. So show that it's parallel, giving a reason. So you see how RS is 1, 3 and OQ is 2S? Good. So that's what we had to show. So and like Antonio was saying, you can clearly see that you can kind of factorize all that with a scalar. So you can see that it is 3 times, okay, that is correct, Denisha, right? So we could simply show that OQ man, right, is equal to 2, 6, which as we said is equal to 2 multiplied by 1, 3. And given that RS is equal to 1, 3, sorry, why am I putting a fraction?
I don't know what to say now.
Right?
Because
Yeah.
how come you have the 2 and then 1 over 3 for the first answer?
Right, because like I said, just like here, you factorize out.
But you don't have to.
We have to.
No.
No, not in the first piece, but here you should, to show that you have a direct connection. So OQ is equal to 2 times RS, right? Show that they are parallel,
Because
giving a reason, right? And there's just one mark. Was that?
the scalar.
Yes. So we could say that there is a scalar relationship between the vectors.
Is
What
that
is the
like,
difference in scalar relation? What is scalar? What is the next one? Equal, and what is the other one? It's 2 again.
Inverse?
Inverse. What is
Equal, inverse, and none actually.
So,
No, equal, inverse, and we are parallel
oh, okay.
between the
and
vectors.
scalar? That'll be the
Chris,
four.
then what is the
Uh-huh.
fundamental or something like that?
Collinear.
No, it's really going back the word.
The only thing with CO with vectors is collinear.
Would-
Congruent is triangles.
So how would you say that?
Uh-huh.
Collinear, like just.
Well, hold on. Let me get. I think there's a question with collinear. Let me get to it, right?
Okay.
Right. 2 times. That's correct. Oh, you said 3. Alright, small thing. That's I making mistakes when I too go. So if you all see me make mistakes, point them out. All right. So yes. So once again, once there's a scalar relationship between the vectors, that means that they are parallel. A scalar relationship simply means that one vector is some number times the other vector, and you could use simple factorization to show that. All right. Okay. Anybody have any questions there?
Yeah.
All right. Let's scroll up one time. Next question. So now all of a sudden they change the question on us. So this is part B to the same Jan 2018 question. XYZ is a triangle. M is the midpoint of XZ. XY is given by A and okay, we need a diagram.
Yeah,
we need a diagram here, right? So let's go on this side here. All right, and let's start drawing. So X, Y, Z. So let's do X, Y, Z. X, Y is A. So the arrow going this way, and the vector is A. Y, Z is B. Y, Z is B. All right. Jonathan Ramesh, this is Jan 2018, Jonathan. Jan 2018. All right. M is the midpoint of XZ. So that's midpoint there, right? M. So first things first, draw a diagram. I know sometimes turning words into a diagram could be a little difficult. They say a picture paints 1,000 words. So guess what 1,000 words paints? A picture. So you just have to go the next way, right? Okay, so I have a little makeshift diagram on the left hand side there. Right, so X, Y. So yeah, just draw your triangle, label the vertices X, Y, and Z. So that's the first step. And then after that, draw in your vectors, draw in your arrows on the lines in the correct direction, put the little common letters, and don't forget the midpoint. All right? Express the following vectors in terms of A and B simplifying your answers where possible. So the first one we have is xz. So how can we get from x to z? Let me put a little different color so we can see. Oh, they want the orange again or not?
Yeah,
Orange, all right. So how do we get from x to z? Do we have a vector? Okay, we could go from x to m and then m to z, but do we have vectors like the small a and the small b? Aha. So we could only travel where we have directions, right? So we could go from x to y and then y to z. Yeah. So you cannot travel along lines where you don't have a vector, like the common letter. We could probably use the other lines to find a vector for that line. Right? So the vector for x, y is a. The vector for x, sorry.
It's YZ.
Y is z. My bad. Denisha is correct. And there you go. 1 mark.
Wait, no. Iris.
What happened?
I thought.
Go say
I
that.
do it first question.
Uh-huh.
And on the second question, and I said, but why are you looking for my second question?
All right. Okay, we're going again. Now we want to go from m to y. We get a different color again, right?
Then half AD.
We do a pink now. So to go from m to y, we have 2 ways we could possibly go at. We could go from m to z, and then from z to y,
Wait, no.
or we could go from m to x,
So why?
and then x to y.
X plus a
Mhm.
minus.
All right, hold on. Let's do it both ways. So whoever did it, whichever way, will be able to see the solution, right? So let's just draw a line going in the middle here. So we could say, let's do the left side first, right? So that's mx plus xy, right? Now we know what xy is. Xy is just given as vector a, not so?
Yeah.
But mx, now mx lies on what larger vector?
ED.
It lies on the vector xz,
Oh my god.
right? So it lies on xz. And m is the what of xz? M is the midpoint. Now, to go from m to x, you are going halfway along xz, not so?
Yeah.
So this is half of xz. But, one more time, forget measure. But,
What?
xz goes in which direction? Left or right? Going from x to z means you are going to the right. So if we are going from m to x, which way are we going? To the left, to the left. So correct, it has to be minus a half of xz. Yeah boy, it's shining. Alright, so we have, now xz was given as a plus b, not so?
Yeah.
Alright, anybody on the live find any the pink too garish? I will change it. Xz is the resultant. Let's check it out. Right? Let's check it out. X is the resultant. That is correct.
I have a question, right?
Quick question. Yes.
From M, both are going outwards towards X and Z and then going upwards.
That's correct.
towards
Yeah.
Y. Okay.
Alright. So when we multiply the minus a half inside the bracket, we're gonna get minus a half A, minus a half B. And we could simplify by grouping together the A's. A minus a half A minus a half B. Now the pink eye. Alright, thanks Tyrion. And what's A minus a half A? When you take a half from a whole,
How it became half minus B?
well, we had a minus a half on the outside, right?
Mm.
So when you apply the distributive law, you multiply the coefficient by everything on the inside, not so? Minus a half by, yeah. And here, if you want, we can actually factorize with a half. And we get what? A minus B.
I did the other way. I didn't
Alright.
the same answer.
Well, actually, let's take a look at that. Let's very much inspect that, because at the end of the day, going from M to Y, we're supposed to have, well, the same or equivalent vectors, or maybe equal vectors, maybe the better thing, right? All right. So what was the? So before I start the next piece of it, does anybody have any questions on this item?
How come it's minus half because it's going in the opposite direction?
Correct, because xz, right? Right, going from x to z goes this way, right? Lisa, when you say do factorizing, you mean like you're talking about like this item here, or like the topic of factorization? Because that's a whole different story right now. Yeah, Antonio. So going to x to z is going to the right. Going mx goes to the left. All right. Do we need to?
Negative direction.
Yeah. Virus is asking if we need to do the last step. You don't have to do it. I don't think it's mandatory. That's just how I was trained to factorize. I just prefer to see that. I think you could leave it, Virus. All right, okay, so let's try the opposite direction now. So let's try mz plus zy, right?
Yeah.
Now, zy is going from z to y, not so?
Yeah.
So that's going this way, which is in the opposite direction of yz.
Yeah.
And going from y to z is given by what vector?
How long have you been on the diet?
B, not so?
Yeah.
2 hours.
So therefore, that would be minus b. Now mz, which is this piece here, lies on what larger vector? On what larger line? xz. Alright, so what time are you finishing? Denisha, I'm finishing 8:30. Right, so we have a little more than an hour again to go. Right, I might stretch it to about 8:40. Right, but I have to lock up after that because I had to go somewhere for a certain time. Otherwise, I'll get licks. I'm kidding. Alright. So MZ. So MZ is the midpoint of XZ. And it's traveling in the same direction as XZ. Yes? But that's the way you said? MZ plus ZY?
I did a half of xz
Yeah?
plus xy.
A half of XZ plus XY? But if you go from M to Z, how you jump across the X?
And to z.
That's what you said. You said a half of XZ, right?
I did from mx to xy.
Right, well, that's what we did here. But remember, going from M to X is going in the opposite direction of XZ. Remember, XZ goes to the right, whereas MX goes to the left.
To the negative.
Alright? So a half of XZ would be a half of A plus B minus B. So we have a half of A plus a half of B minus B. Another half B minus B. As minus a half B. And we could, but don't have to, factorize with the half.
But I got a half m plus b. I mean a half. Yeah. That is.
Just Google it. Oh, okay. Can I scroll down? Yeah, that's it. Yeah? You mean you want to scroll up so you can see diagram?
No, but I'm doing.
Alright guys, we'll put it on pause for a minute just to get the brains to relax. Because we're gonna switch topics now to matrices, right? But I'm gonna pause here for a second. Why is it half of A plus B? Adela, am I saying that right? Okay, it's a half of.
We go over to the last one. If you give it.
You have A plus B or A minus B? I have A minus B. Right?
So anybody when you last night?
Yeah. I don't think Rihanna got, so let Rihanna have it, right? Okay, so I'm gonna try to answer Adela's question. Right, so once again, we want to go. Let me erase a lot of these extra lines here so we could kind of re-explain it from scratch, right? Yeah.
This one is a low end.
Which one is that? Or the next one? Or the 2016? Sorry, that's 2017.
Yeah.
Yeah.
Oh.
I was so confused.
Because the midpoint, Adela, right?
And I know we have
So it's half the line X. That's correct,
I know we have
Denisha.
reference to it as well.
Yeah, but you know what? I think we should probably tackle that question and then move on. Alright, guys. Okay, guys, we're gonna do one more vectors question, which is the May 2017. Alright. So Adela, I had to bypass that, but to answer your question very briefly, Denisha is actually saying the correct thing. Right? We're going to go from M to Y. Right? You have to go from M to X and then from X to Y. And what ends up happening is MX is a half of X, well, minus a half of XZ. XZ is A plus B. And then you have minus a half by A plus B. When you expand the brackets, you get minus a half A minus a half B. And then you group together the A and the minus a half A. And A minus a half A is a half A. Alright, and then of course, you have a half A minus a half B, and I chose to factorize. You don't have to factorize. Question, for the first one, can you also do half of ZX instead of negative XZ for the first one? Oh, this one? Oh yeah, you can do that. Half of ZX and negative XZ is the same thing. Right? That's good earlier, right? Oh, I like your icon or your avatar, your little profile pic, the panda with the dab. That's pretty cool. Alright guys, okay, sorry to rush, but I want to do the May 2017 because that was an interesting one.
Why do you have this question?
Yeah. And we have to do matrices after, and I had to squeeze in circle geometry. Alright.
What do you mean? You have to just go from OP to
Alright, let's go back to a slightly more sober color. Stop scrolling back up the man. Behave yourself. Behave. Alright. So, alright, are you all ready?
No. Yeah.
Alright. The position vectors of points P and Q relative to an origin. Relative to an origin means that they are position vectors, hence position vectors. And all position vectors start at the origin. The origin is denoted by what letter? O. So that's O.
Sorry.
Yeah. The coordinates of the origin are 0, 0. So you're correct. So you have OP and OQ. OP is 4, 3. OQ is 5, 0. The diagram below shows that PR is equal to 3 OP and QS is equal to 3 OQ. So let's get some colors going there. So it shows that PR, so PR is the whole line, and that's 3 times this smaller piece here. Right? Similarly, QS is this whole thing here, and that's 3 times OQ.
So it's 4.
No, it's just 4 times that piece. Sorry, it's just 3 times that piece. Right? But what that implies, therefore,
Once you add it.
is that OP, you can't really add it because they're in the same line. Right? OP, therefore, is 1/3 of OR. And it also implies down here that OQ is 1/3 of OS. Yeah, Vish, this question was a little tough. I wouldn't lie. All right, but like I say, you had to take it step by step.
Yeah.
Make it make sense. Break it down. Like the man from Slapped Up Chip, break it into pieces. All right. Okay, and take it one thing at a time. Right. The first thing they want is OS. Right. Now OS. What are we getting from O to S, boy? Oh, that's from here to here. Oh, good. I wasn't even seeing S then. Wow. All right. So we want to go from O to S. So to go from O to S, what letters we have to pass through? We have to go from O to Q and then Q to S. So OS is equal to OQ plus QS. Now OQ is given up here as what vector? 5, 0. Hold on. Right. 1 second. Yeah.
You multiply everything by 3.
And QS. QS is 3 times that. Right? Also, Jono, you were right. Sorry. My bad. My apologies. Jono was correct. 3 times 5, 0. Because it said QS, which is this piece here, is 3 times this piece. Alright? Alright, so you have 5, 0. What's 3 by 5? 15. And then we add the corresponding horizontal components. And we add the vertical components. And we get what was that? 20, 0?
Yeah.
Alright. How are you looking? Everybody okay with that?
Yeah.
Alright. Anything went wrong somewhere?
No.
Delma, we are going for grade 1 tomorrow, people. Yeah, aye for that? Go for it. When you see the exam paper, what to do with it? Pick up something. Start to run with it. Run. Alright, cool. Sorry. You get distance, speed, and time. Run with anyhow. Sorry. Alright, are we okay with part 1?
Yes.
Alright, moving on. PQ, boy. To get from P to Q.
I have to go from
I was have to look at P to Q, boy.
negative to P.
Right, so check it. To start from P and go to O. Right, and then go from O, you could go to Q.
So it's negative
OP.
Right, that's what I wanted to hear.
PO to OP.
Right, so PQ. Go right up. Correct, you have to go from P to O, and then you have to go from O to Q. Yes, I? Right, PO is negative OP, right? So yes, you're correct. So PO is negative OP because they're going in the opposite direction. Alright, let's go across. Now OP, what was the vector for OP? They told us it was 4, 3. So is the negative of that vector. So it'll be minus 4 minus 3. And OQ is just 5, 0.
If I were to put
OQ. 50.
So minus 4 plus 5 is 1. Minus 3 plus 0 is minus 3. Not 1, not 2, but 3. Sorry. Ooh, that's a bit so.
Easy things.
Right, sorry, Brian, I had a question.
oh no, I didn't get this.
Okay, cool. Under ruler. What's the ruler?
RS.
No,
So
I'm not gonna
you
unplug
said,
this. I'm gonna unplug that for now.
negative OP
Uh-huh.
was like, you have to put like a 3 times OP, you know what I mean? Would we have to put the 3 negative or the 4 and the 3 negative?
Both vectors, both components have to change direction. So
All would have to be negative.
if it was positive,
Yeah.
if each one was positive, they'd become negative. If they were each negative, they become positive.
Even the scalar factor doesn't go up, right?
The scale factor wouldn't change. Well, it wouldn't change sign, right? The scale factor is simply how much bigger or smaller, but the components are the directions.
Okay.
All right. So don't change the signs of both because then it will just cancel back out.
That's right.
All right. All right. The next item is so we just did PQ. All right, and now they want RS. So sorry, I know the people in line not seen it, but they want RS. I'll just show you. RS. I'm trying to keep it near to the diagram so we have context.
Negative 4 plus 4.
Good, I'm on shooting. Yeah, it looks intimidating, but yeah, when you go through it, like I say, you gotta break it into pieces. Right? Like in one of my recent videos, I said it's like trying to eat a hamburger in one bite. Don't stuff the whole thing in what they want to choke. Don't do that.
RS is R.
You bite a piece and you savor it.
Wait,
Right, let's go. You want orange? Let's do orange now.
You ready for Geo?
Right, so RS means that I go from R to O, and then from O to
So it
S.
would be from R to P, then P to O.
Well, R to P and then P to O is the same as saying R to O,
Okay.
right? So let's work out here. So RS
No, you
Right.
have please.
plus, sorry, not R, sorry, it says RS is equal to RO plus OS. Now going from R to O is the opposite of going from O to R. That's OR, negative OR, sorry, plus OS. Now minus OR, right?
Negative 4.
Right, so OR, that was OP, plus PR. Orange is my favorite color. Alright, Shemaya. I'm happy it's your favorite color. Alright, so it is a
Or, right?
yes, it's minus OR. Yes, orange is a nice color. Alright, OP plus PR. Sorry, minus of OP plus PR, right? Now, OP, let's just scroll up a little bit, was 4, 3. Right? So that's minus 4, 3. And then PR, so they said PR is 3 times OP. So it's 3 times itself. You have to P? Oh, okay, right. And then OS, they told us we found OS already. So that's 20, 0. Alright. So now we have I just doing all the steps, right, to show all the working in case anybody not sure how I get any particular partner. I don't want to skip out anything assuming people follow all my steps. I'm not trying to say anybody's stupid. I'm just saying sometimes I do things and assume and my assumptions are not always correct. Alright, that's negative. So 4 and 12 is 16. 3 and 9 will give us 12. Plus 20 is 0. Aha! So we have minus 16 plus 20.
Minus 16 plus your positive.
Right, but notice that on the
Oh,
outside.
I see.
Aha, you see it, right. So let me put that around a space, boy. Jam. Jam. Right, and minus 16 and 20 is 4. 12 and 0 is 12.
Did you just write over the same thing?
Did I?
Oh, no, never mind. No, you're putting minus in the bracket.
Yeah, minus, yeah. So, sorry, minus 16, minus 12, my bad. Standard deviation and speed time graphs. Shema, you're predicting, boy? Yeah, but if you're predicting, give me a lot of numbers now. I wouldn't mind winning a little lotto. Even 5 numbers are good. I could use you can use a, sorry. Alright, so that's how you find RS.
Stay tuned. Geometrical.
Right. So that's the part. Yeah. So that's the part there, of course, that's the working part.
Parallel.
No.
Hey, Brian, you see? Yeah, bring it back now. Let me take a quick
Q
peek.
and RS is parallel.
Speed time graph.
Larger.
RO plus OS. That is correct. No, RO is minus OR, eh? Okay. Okay, alright, I can live with that. No, but OS, look, there's OS here. See? OS, 20, 0.
Oh, I use this.
Yeah, you use the single bit. 0. Alright. Yeah.
How is it positive 12 if the minus 12 is added to 0?
Sorry, you are correct. Minus 12. How come you have to add 4, 3, 12, 9? Right, so check it. The 4, 3, and 12, 9. Let me get a different color just to kind of highlight what's going on here, right? Well, that's the problem with the orange. Alright. This, the 4, 3, and 3 and 12, 9 were added because the 4, 3 was this piece down here, and the 12, 9 was this piece here. Alright? Yeah, sequences for sure. That's always question 7 now. It was question 8. Alright, guys. Okay, arm and leg. Alright. Okay, so binary looking like an obvious question tomorrow. Ooh. Delma, don't call that, you know. Don't call no binary, you know.
Binary what?
They're not hard, but I mean.
Binary numbers?
Yeah.
But, oh, I don't know.
Yeah, but not everybody does IT.
Just do it by 2.
2, 8, or 16.
Right.
You want hexadecimal now?
Yeah.
I know what 16 is, right? Yeah. Alright, state 2 geometrical relationships.
Parallel and it's 4 times larger.
Alright, hold on.
What are you going back and forth?
Binary is cake.
Come look, just watch mine. Your time to waste on.
When did subtract, this is a negative sign. Right, so that's what I did. See, negative 16 and 20 gives us 4. Negative 12 and 0 gives us negative 12. Sorry, nobody bracket it.
Chris,
Yeah.
does it matter which direction you did it? Because I did it from OS to negative OS to OR, and I got negative 4, positive 12.
Well, direction matters. Direction is important. The vector they asked us for was RS.
Yeah, why you went
So you had to start at R and go to S. So if you did minus OS plus OR, you actually did RS. Sorry, SR. Sorry, my bad.
That would be minus.
Quadratic equations tonight. Tavania, sorry if I'm mispronouncing the name. I'll see what I'm gonna do, but my plan was just to do vectors, matrices.
Circles, geometry.
Oh yeah, we have some circle. What's that?
What she just asked?
Quadratic, where we did simultaneous equation. We had one linear, one non-linear. So we had. And that. Oh yeah, Tavania. I'm not sure how. Real sorry, I can't say it properly. You can check out my live from last night. Wouldn't it be minus OP plus PO? OP plus PO would be 0. I mean PR. OP plus PR. Yeah, that's what I have. Plus OS. That's what I have. Right there. Selena. Tavinia.
This is for
Tavania. Right, that's the second one, sorry.
Oh, is that the one from yesterday?
Right. Yeah, Selena. That's what I have here.
You have it?
Minus OP plus PR, right, then plus OS. So, okay, right, I see it. Niceties and non-cities. Alright, sorry guys, I get inside track with some stuff there. So, state 2 geometrical relations between PQ and RS. So, when they're asking about geometrical relationships, they could either be equal, inverse, you could have a scalar relationship, right? And if they have a scalar relationship, they can be parallel. Best I go all night because there's many people who don't understand certain stuff. Yeah, boy, I would love to go all night, boy, Delma, but I working since about 6 in the morning, so I cannot go all night. I'm real sorry. All right? Yeah.
Relationships are what? Equal.
Sorry, I took it off. My bad. It could be equal,
Scalar.
inverse. You could have a scalar relationship. I almost forgot there could be collinear.
What is collinear?
Collinear means they lie on the same line, right? So let me just scroll back up real quick so I can show you guys what I mean by each of these, right? Maybe not each. Equal vectors are where they have the same components, right? So for example, if I had a vector 1 minus 2, I had a next vector 1 minus 2, they have the same horizontals and same component, same verticals, right? So this will be equal. Inverse, let's say I had the same 1 minus 2. If I had a next one going 1 minus 1 and 2, those will be inverse, right? They go in the opposite direction.
Wait, well, that's inverse.
That's inverse, right? A scalar, so let's say I had a 1 minus 2, and I had, let's say, 2 and minus 4. This one on the right hand side is clearly 2 multiplied by the first vector. So that's a scalar relationship.
What is collinear?
Right. Collinear means that they lie on the same line.
Wait, can you do
Uh-huh.
scalar one more time?
Right. So if I had a scalar one, if I had, let's say I had 1 minus 2, and I had 2 minus 4, or let's say I had 3 minus 6, 5 minus 10, I could factorize these. I'll get 2 by 1 minus 2. I could get 3 by 1 minus 2, or 5 by 1 minus 2. So you see how all these kind of common?
Yeah.
And they tie back to the first one?
Yeah.
Right. So that's a scalar relationship. And they will be parallel as well.
Okay.
Right? Once you have a scalar relationship, you are parallel. Whether you're going in the same direction or opposite is also determined by the
So
signs.
once it's scalar, then parallelism.
That's correct. Right. Okay.
If they have the same line, they also be parallel.
Correct. Let me show you guys an example of collinear points, right? So let's say I have A, B, and C.
Points that lie on the same line.
Points that lie on the same line, that's correct, right? This here would be an example of collinear points. Right? Let's say this vector here is simply A, and this vector here is, yeah.
No, but that's the answer.
I don't know, I have to check and see. PQ and RS? PQ and RS. No, they're not collinear, not at all. Look at where PQ is. Draw a line from P to Q and then draw a line from R to S. They're totally different in terms of where the location is. Right. So in this particular case, let's say we could go all the way from A to C, right? That would be AB plus BC. Viresh, collinear means that the points lie on the same line. So you see like how A, B, and C here lie on the same line? That means that they're collinear. Kerwin's supposed to go line later, right? Well, if Kerwin going line later, make sure and jump on that one too. Absorb all the maths you can absorb. Right? Yeah, because I locking off in a little while here. Alright, sorry I couldn't stay longer, guys, but yeah.
It was 4, 1 minus
I have some stuff to do.
Factorize it in what?
4.
Okay.
And then in brackets.
So Chris, this one is collinear.
Yeah, Kerwin has some real good stuff. Sorry.
This one is collinear.
No. I was just showing an example of collinears, right? Notice as well with collinear points.
So it's equal inverse and
Right, scalar, right. Alright, now let's take a look and see the vectors that they're asking us about, right? What are the vectors they're asking us about?
PQ and SR.
PQ and RS. Alright, so PQ was something we worked out earlier, not so?
Yeah.
That was 1 minus 3, not so?
Yeah.
Okay, so PQ was 1 minus 3. RS, we worked out just now too, right?
Yeah.
That was 4 minus 12.
Yeah.
That's in the orange up here, right?
Yeah.
Alright, 4 minus 12. 4 minus 12. Whoops. Alright, now, could we factorize the RS one? Pull out the 4, and what we get? 1 minus 3. So what can we say here? Are they equal?
yes.
Yeah. Well, I put that.
Are they the exact same vector? No. They have a common factor.
Yeah.
Right. So there is a scalar relationship. So
Scalar and parallel.
right. Correct. We can say that RS is how many times bigger than PQ? 4 times bigger than PQ. Alright.
Yes.
And they are parallel to each other. collinear is, yes, they are actually, yeah, if you look at collinear points, let's say you had vector AB and then you had vector BC. Vector AB and BC would be parallel. And the thing is, they would have a point in common, right? Matrices, how do you know when it's singular? Actually, I'm going to do matrices now. So if you just give me 2 minutes round of this question, you'll see some matrices in action, right? So yes, so for collinear points, yes, they actually are parallel to each other, but they are parallel along the same line, right? Correct, Shemaya. All right, okay, guys. We have to move from vectors because we have just about 45 minutes. Again, we have to do matrices and somehow squeeze in circle geometry. I'm not sure how we're doing that one, right? But let's. We gotta give it a shot, right?
Circle geometry,
But a butterfly
Alright.
effect out there.
So those on the live are shifting to matrices now, right? If you need to go back and see anything, you can do so after when the live. It's take a couple. It might take an hour or so for the live to go up, eh? Alright, guys. Shift into matrices. Alright, so you all have any. Does anybody not have the matrices handout? Anybody need it?
I have it in my phone.
What do you mean not with you right now? If you don't have it, tell me fast. What's that one there? Yeah.
Are you sure you didn't give Liam yours? You have your circle geometry one?
Thanks, Brianna.
Here. Good catch. Alright, we have 5 questions here. Let's see if we can do maybe three or four of them and then shift to some circle geometry. So for those on the live who are watching, these are the years in that order. But I believe I should have them visible as I scroll down on the bottom of the page. Or at least I will call them out for you. Alright. First question, as Leon correctly said, Jan 2019. 3 matrices are given as follows. PQ, right? Q, right? R. Using a calculation to support the answer, explain whether matrix P is a singular or non-singular matrix. Aha! So this is the same thing Tavania was asking about. A singular matrix is one that has a determinant of 0. If you have a generic 2 by 2 matrix A, B, C, D, the determinant is A, D
Minus BC.
minus B, C. Yes, Stefan, I back about our one change now, boy. Sorry, I realized I was talking to myself plenty when I talking to all. Sorry, whatever. Right. Sorry, my class watching more funny. Who is Stefan? Right. Anyhow, so let's take a look. So here, to find the determinant of P, which can also be expressed as determinant of P, we simply have to multiply the elements on the primary or leading diagonal and minus the product of the elements on the secondary diagonal. What's minus 1 by 5? Minus 5. What's 0 by anything?
0.
And minus 5 minus 0 is minus 5. Is that equal to 0?
No.
So therefore, if it's not 0, is this matrix singular or non-singular? Non-singular. Right? So matrix P. So boy, I have bad news. What's the bad news, boy, Stefan? Singular is where the determinant is equal to 0. So if the determinant is not equal to 0, right, it is non-singular. Are we okay with that? Yeah.
When you're doing it's only for the inverse you put 1 over.
Yes, only for the inverse you put 1 over the determinant. That is correct. Alright. Okay, so that is that question there. Scroll up. Sure? Non-singulars have an inverse end. Non-singulars have a determinant and then would then have an inverse. That's correct, Eka. Alright? Because the inverse is 1 over the determinant multiplied by the adjoint.
What do you do when it is a singular?
If it is a singular matrix, it cannot have an inverse because the formula for the inverse is 1 over the determinant. So if the determinant is 0 and you put 1 over 0, it's undefined.
Okay.
Alright? They could ask the preliminaries. And then they would say, could you find the inverse of this matrix? They might ask, could you find the inverse of this matrix? Right? Or could this, like they might give it the simultaneous and say, could you solve this using simultaneous equations, using a matrix method? And we know that eventually you have to find the inverse. And if you can't find the inverse, then you cannot solve it using a matrix method. So yes, they could ask in a tricky way. Alright? I feeling real sad by. Why is that, boy Stefan? You're welcome, Decker. Alright, scrolling down. Given that P by Q is equal to R, determine the values of A and B. So P multiplied by Q is equal to R. So once again, so P was the matrix minus 1, 2, 0, 5. Q was the matrix AB. And R was equal to 11, 15. Back for circle theorems. Alright, cool. Alright, so P by Q is R, determine the values of A and B. So let's check it out, right? So to multiply 2 by 2 matrices, or to multiply matrices that are compatible for multiplication, you have to multiply the row by the column. So if you multiply row by column, right, that will give us what? So it's minus 1 by A plus 2 multiplied by B. You could do the inverse. That's one way to do it, but you see, what is the first element in the second row?
0.
0. What is 0 multiplied by anything? 0. So check what's going to happen, right? What's minus 1 by A? That's minus A, right?
Yeah.
2 by B is 2B. Hi Faith, good night, how are you? So we have 0 plus 5B. Right? Now this is equal to 11 and 15. So, yeah?
Oh, yeah, okay, you just explained that. I was like, A by 0 would be A by the rest.
A by 0 is 0, yeah. Minus A plus 2B. Adela, isn't that simultaneous equations? It is actually simultaneous, Adela, you are correct. But the interesting part about it is that in the second equation, you actually just have 5B, because 0 plus 5B will just give us back 5B. And we could use that second equation to solve for B straight away. Right? And now that we found the value for B, we could actually substitute that back up inside of the first equation to solve for A.
So that's faster.
Yeah, this is way faster than trying to find the inverse and then multiplying it by this matrix here.
I mean, I kind of like it.
We could do that. Alright, so minus A plus 2 multiplied by 3, right, as equal to 11. So minus A plus 6 is equal to 11. So you could say, alright, so minus A is equal to 11 minus 6. What's 11 minus 6? 5. So if minus A is 5, A is equal to minus 5. Adela, Q is equal to P inverse by R. Adela, you are correct. You could do P inverse multiplied by R. Alright. You lost your timetable and you're feeling sad. Adela, yes, you can. Yeah, boy, Stefan, you have to find that timetable, boy. Or talk to your principal one time in the morning. Call the ministry, call somebody.
And they don't really call me.
Genevieve, good night. Good to see you on the live. Yeah, from POA.
Oh,
Yeah.
Chanel. Oh no, that's the next one.
Chanel, you mean Zalia?
Is Zelia the next one?
Yeah.
You want to sit here and then who's the next one?
Yeah, Genevieve, Zalia sitting in the corner.
Oh.
I haven't had a Chanel since your sister. When you do the matrix, you end up with a simultaneous. Yes, that's correct. Manoj, yeah. Hi, sir, good night. Hey, Shivani, you come back there. Nice, good to see you. Yes, Chris, I need this. Alright, cool. Alright, so yes. Now, somebody in the live was saying that we could use the matrix method, which is to find the inverse of P. Let's just do that for practice. Alright, but just by the way, just because it was a simultaneous equation in a matrix question doesn't mean you had to find the inverse. Right? When we multiplied it out, we actually got this system of equations here. And if you look at the second equation, that will give us the value of B right away. So doing the inverse is doing a lot of extra work, right? Because look at the instruction. Did they say specifically using a matrix method? No, they didn't. They just said determine the values of A and B. So because of that, you are free to solve it. Well, actually, yeah, because you had to multiply. Yeah, you had to use matrix multiplication to get the system of equations in the first place. All right, Ariella, good night, good night. Wes, good night to you too. All right, guys. Sorry, I thought I heard somebody calling. Let's just answer part 3 real quick because we wanna move at some pace because we have the May 2018 as well to do. Sorry, the Jan 2018 Then I forget me. Oh shucks. And then in May 2017. So I want to get through those questions because I want to take a look at some circle geometry. All right. State the reason why matrix product QP is not possible. So matrix Q, if we pull back here, we will see our value for B and our value for A.
For matrices, well, a 2 by 2 matrix can be multiplied.
Minus 5 by 3. By 2 by 2, you mean?
Yeah. A 2 by 1.
Right, so Liam is correct. Liam is saying that the order of this matrix is 2 by what? What do you need, boy? For the charger?
Yes.
What are some acrobatics here? Right? This is a 2 by 1, but this is a 2 by 2. The way that we know whether or not matrices are compatible for multiplication is looking at the number of columns in the first matrix and the number of rows in the second matrix. Are they equal to each other here? No. Therefore, they are not compatible for multiplication. Or you can just say they cannot be multiplied. Right? Yeah. PQ is very possible, right? If you wanted to multiply P by Q, right? That's minus 1, 2. Yeah, we did it on top. Yeah. Minus 5, 3. So in this case, this would be a 2 by 2 by a 2 by 1. Would these two be equal? Yes. Right? So if the number of columns in the first matrix is equal to the number of rows in the second matrix, the matrices are compatible for multiplication. And the resultant matrix would have the number of rows from the first matrix by the number of columns in the second matrix. Alright? Alright, so that was Jan 2019, guys. Right? So some relatively simple-ish stuff. Right? Now we're taking a look at Jan 2018. Why are you calling me man, Chris? Jenna know me a long time. Sorry, what? As in you're cool?
Yes.
Okay. Alright, 126. Let me know if you get it any better, right? Sorry, what?
Yes.
Alright, so you can say the number of columns in Q is not equal to the number of rows in P.
That's right, but not equal.
Yeah, I equal sign with a stroke through it. Alright. Alright, I'm scrolling back on to Jan 2018 shortly. Let me know when, right, Antonio?
Yeah, down there.
Alright, cool. Scrolling back down to Jan 2018. Matrices A and B are given as that and that. Determine A inverse, the inverse of A. So, like we said, A inverse is equal to 1 over the determinant of A multiplied by A adjoint. And that adjoint has nothing to do with weed, right? Different kind of joint. So this is 1 over the determinant. So that's minus 1 multiplied by 2 minus 0 multiplied by 3. And now, for the adjoint, you swap the elements on the lead diagonal, and the elements on the secondary diagonal take the opposite sign of what they had originally. Now 0 is neither positive nor negative, so you can't change the sign of 0. Alright, now, what's minus 1 by 2? Minus 2. What's 0 by anything? 0. So minus 2 minus 0 give us what? Minus 2.
1 over minus 2.
Yeah, so 1 over minus 2. Now, I prefer to leave the inverse in this form. Some teachers insist that you need to multiply the scalar on the inside. So minus a half by 2 is minus 1. Right? I prefer this one here because it makes things easier to work with going forward. Right? Yeah, that's it. It's just to find the inverse. You found 1 over the determinant, multiply by the adjoint, and you're good to go.
Wait, why you? Oh, you said I normally leave it.
Yeah, I normally leave it too. Hello? Yeah, I mean, you could, but to me they mean the same thing. So what is really the difference? Yeah, the fractions make it messier to find the next part. Check it, right? Now, I'm not saying you shouldn't work at fractions. You can if you want to. That's all well and good. Now show that A inverse by A is the identity matrix I. So A inverse, as we just found, is minus a half, 2, 0, minus 3, minus 1. And A was a minus 1, 0, 3, 2. Right. So now we have to multiply those two matrices together. Let's go. So we have, so we're going to maintain that determinant, well, the 1 over the determinant on the outside, right? So remember, when you multiply matrix, you're multiplying row by column. So first row, yeah.
Does the minus one change? Or just switch?
Is it no? It's
Oh no, it's
Yeah, minus 1, 0, 3, 2.
Okay, I know.
Alright, so row by column. So 2 by minus 1 plus 0 by 3. Now we're going again. So same first row, but second column now. So now we have 2 by 0 plus 0 by 2. Alright. Now, second row, first column. Yeah? Alright. And now, same second row by the second column now. Yeah, there's a lot of stuff. Right, okay, cool. Equals, let's see what is equal to. So we maintain the negative half to the outside. 2 by minus 1 is minus 2. 0 by anything is 0. Sitting across 0 plus 0. Minus 3 by minus 1 is positive 3. Minus 1 by positive 3 is minus 3. Sorry, let me shift that across. I don't know how come I went so misaligned. So 3 minus 3 by 0 is 0. And then we have a minus 1 by 2 is minus 2, right?
Yeah.
Alright, so it's shaping up to be exactly where we want here, right?
Yeah.
What's minus 2 plus 0? Minus 2. 0 here. 3 minus 3 is 0. And 0 minus 2 is minus 2. And now, when we multiply that minus a half by everything on the inside. So minus a half by minus 2. Minus a half by 0. Minus a half by 0. And then minus a half by minus 2. Minus a half by minus 2. A minus by a minus is a plus. And a half of 2 is 1. Anything by 0 is 0. And minus a half by that is 1. Okay, I'm now seeing some new people. Right, good night. Kevin, good night. Yes, I heard the accounts was challenging. That's how it is sometimes, boy. And I heard a lot of people were in uproar about the statement of changes in equity. I even spoke to Mr. Cooper and he was saying that was unexpected.
He told me he told me that was on the syllabus when I asked him.
Right. Technically speaking, it is, because the syllabus says you have to know how to do financial statements for a limited liability company, and which it is, right? It's just that they've never brought it before. They specifically mention it on the Form 6 syllabus. So if that's the case, they should mention it specifically or explicitly on the Form 5 syllabus.
So what do you mean? They're not wrong.
I don't know, because you see really and truly what that is correct. The statement is correct. It is a part of the financial statements, but I don't know if anybody would have known that at the Form 5 level. It's not impossible. It's not impossible. But it's just not something I have ever taught at the Form 5
It
level.
should be generous and just give us EAP.
Yeah,
Well-
they're not wrong, but I think they should just still give us.
Well, yeah, that's a good policy, Kevin. You have to attend to everything. Tavenio. Income statement for limiter. Sorry about that, Tavenio. Next time.
Please, yeah.
Anyhow, give it a shot. Tavanio. Sorry, I said the name wrong. I can't make all that money go in the drain. I answer every question here. Alright, cool. We're going again. So we've just found the identity matrix. Determine the matrix A squared. Now when you square something, what are you actually doing?
multiplying it by itself.
Very good. You're multiplying it by itself. So you have to multiply this matrix by itself. Yeah, sorry? What, the 2?
Yeah. I get pretty.
Look like a Z. But it can't be A to the power Z. It has to be A squared.
Yeah, it is.
Right. Why will they keep calling back the house? I don't understand. See them only call the house. I'm not answering. Okay, so once again, row by column. So we multiply minus 1 by minus 1, and then the 0 by the 3. Alright, and then we go in again. Same first row, but by the second column now. So we have minus 1 by 0 plus 0 by 2. Right, that's the top row. Bottom row now. So we have 3 by minus 1 plus 2 by 3. And now, I do something wrong?
Oh no, it's me. I did 3 by 3.
And you have 3 by 0 plus 2 by 2.
Let's go, boys.
Right, yeah.
This way is kind of easier than the letter thing I was doing, the AD thing.
I know.
Yeah,
It is correct for what it is, but it is a very cumbersome thing. The more you practice doing it, is the easier it becomes to remember. There's no need to write that formula out.
by that.
Exactly.
Then that by
Yeah, horizontal by vertical. Long story short. Minus 1 by minus 1 is positive 1. 0 by 3 is 0.
So set up a comment speed.
Just fling them right in. Where that came from?
I don't know.
Where it fell from? Oh, no. It was in front of your foot. Don't worry about that. There's no scene. Then we have minus 3 plus 6. And then we have 0 plus 4. What are we going to get here? 1, 0, 3, 4. Alright. Yeah, okay. If all they want to go there, there's no scene. Or they could come back and check it after. When it posts up. Alright. If they want to stay, that's cool too. I appreciate it. Alright.
Don't forget to like and subscribe.
Yeah, don't forget to like and subscribe. Thanks, Leo.
And share.
Like, share, and subscribe.
And the comment in the comments.
Like, share, subscribe, and comment. Again, school and social media here. Explain why the matrix product AB is not. Well, didn't ask it just now?
Yeah.
Why is AB not possible? Let's see what A was again. So A was the matrix minus 1, 0, 3, 2. B was the matrix minus 3, 2, 1, 1, 4, 6.
So then it would just
So what's the order for the first matrix? 2 by 2. What's the order for the second matrix? 3 by 2. Remember, you have 3 going across, right? Are these two things equal?
No.
No. Therefore, they are not compatible for multiplication. So the number of columns.
And not the same as number of rows.
Correct. The number of columns in matrix A is not equal to the number of rows. It's about time.
Yeah,
In matrix B. Thank you very much, Deck. I appreciate that. Without calculating, state the order of the matrix product BA. So
3 to 2.
let's see, right? Without calculating, 3, 2, 1, 1, 4, 6, and then minus 1, 0, 3, 2. What's the order of matrix B? That's 3 by 2, right?
Yeah.
And that was 2 by 2, not so?
Yeah.
Are these two equal?
Yes.
Yes. If they are equal, the resulting matrix will have the number of rows in the first matrix and the number of columns in the second matrix,
Alright.
which is 3 by 2. So Jono was correct.
Okay.
And correct is right.
Wait.
And right is the opposite of left. Anyhow. Yeah, no, see, no, scroll, zoom out a little bit so it fits a little better. That good?
Yeah.
Nice.
Yo.
Yo.
Woke up today.
Uh-huh.
English, I'm like,
You woke up today in the English?
No, I woke up today. I was like, damn,
Why
I
you
didn't
so
total in this
concerned?
English.
Can you see he wake up in the English? Or like you, hold on. You sleepwalk to the English exam or you fell asleep in the English exam?
Nah, I didn't fall asleep. I
Oh,
wanted
well,
to,
a good thing is.
So
Uh-huh.
I woke up today. I was like, damn, I get total in this thing I want. And then it occurred to me, wait, I have like English that's really.
Yeah, that's it.
yeah, yes, the math SB.
Alright.
I got 19 out of 20 in my math SB.
Wow, that's pretty good.
I don't know.
Alright, guys, we're gonna do one more. The 27. Hold on, did I do this question twice? Find the inverse.
You lie, though.
Multiply that by that, right? Okay.
You got 20 out of 20. Yeah.
What are you gonna do?
my gosh.
Alright, guys. We'll do the 2016. The 2017 question was very, very similar to the 2018. So we're gonna skip that one. 2016. So the next question you're going to see is this question here. But look, they said, wait, what? Hold on, wait. Did I skip something wrong here?
No,
it's a conclusion.
Yeah. So it's more or less the same, right? Find the inverse, multiply the matrix by the inverse, and then a simultaneous.
Mute with an X.
Mute with an X? That's Mukstedt.
No boy.
Or Mutex.
Chuck, what is it?
Nicholas.
You know what it is. Chuck
Slam
slam.
times 2.
Chuck slam times 2. Not enough money making.
Right. I think the 2016 one is more worth doing because it's a little more involved. Yeah, because you actually have to work out that one. Alright?
No, just start with that part B.
Yeah, which one you bought? It says, it says page 29, it starts with a part B, determine the value of X for which that matrix is singular. What is a singular matrix again? One where the determinant is equal to 0. And how do we find determinant again? You multiply,
D minus
right.
BC.
You multiply the elements on the lead diagonal and you subtract the product of the elements on the secondary diagonal. Right, so we put it now. They want the value of X for which this is equal to 0. 3 by 4 is 12. 2 by X is just going to give us 2X. So to solve for X now, we can simply add 2X to both sides of the equation. And then how do we move that 2 from that X?
Bring it over.
How is it attached? What operation attaches it?
Division.
Well, multiplication attaches it. So to move it, you have to do division. And whatever happens on one side of an equation, happens on the next side. Therefore, X is equal to 6. Was that sorry?
It's non-singular.
No. They asked us to find the value of X which would make this matrix singular. Right? Determine the value of X which makes.
But then the 6 would minus. The 6 would minus. No, 6 by 2 is 12. So 12 minus 12 is 0.
Yeah, that's correct. Alright, next. N and P are two 2 by 2 matrices such that Determine NP. National Petroleum. Alright, cool. Multiply that out, guys.
Wait. What? Why is that only? Why is that so little bit marks?
Yeah, that's a good question. Why is that multiplication 1 mark, boy?
Kind of making no kind of sense before.
Not enough sense making.
Not enough work retaining.
Aye. Alright. Row by column. So we have 4 by 1 plus 1 by 2. And 4 by 1 by 5 by 1. Sorry, 4. So 4 by 5 plus 1 by 1. 1 by 1. I'm sorry. Yeah, it's a bad one. It's a large one. Alright. I had that other guy was here a couple in 2017 class. He went to Fatima. DJ 96. What name is? DJ Lani. Jelani.
Hey!
Yeah.
Not enough money making, right?
Yeah.
No?
Well, I think he does with the sample.
What's that about? He's the same one.
He had juvenile diabetes.
Okay.
Arthritis. Sorry, I said that. Well, now we know why I'm not a doctor. I did tell him, man, boy, you're getting a heart attack, and the man have arthritis this time. Yes, well, good. I would have said him. See, our stomachache, take Optrex. For the stomachache, yes, drink all. Right, 4 by 1 is 4. 1 by 2 is 2. 4 by 5 is 20. 1 by 1 is 1. Right. 3 by 1 is 3. 2 by 2 is 4. 3 by 5 is 15. 2 by 1 is 2. Nice. So we have ticks 21.
Wait, what?
7. Yeah, ticks. Right.
I'm stupid.
What happened?
What is. What the.
There's no entry, like,
Stop it. Come back.
Oh, look,
Alright.
I'm figuring out, like, just explain that.
Should have been at least 2.
Yeah, 2 marks at least. The min, only marks is only there. Alright, cool. Alright, so we okay with that item there? 621, 717?
Yes.
Oh, wait, hold on, just write down that.
Right, now that's equal to n by p. What does commutative mean?
The steepness of multiplication.
What is 2 by 3?
6?
And what is 3 by 2?
6. That is
That's commutative. Addition and subtraction are commutative. Doesn't matter the order in which the terms are. You get the same answer. That's commutative, right?
That sounds good.
Matrix multiplication in most instances is not commutative. Because look, this here is the answer for n by p, not so?
Yes.
This is p by n. Are they equal?
No, yes. No.
Are they equal?
No.
Oh, you're looking at, okay, I didn't the word columns. No.
Alright. So we can say that np and pn are not equal. Therefore, matrix multiplication is not commutative
Alright, stop.
in most instances. Multiplication is
Multiplication.
yes. English don't pass already. I have bound to speak right. I don't care right. Boy, everybody go on, nobody laughing at my jokes. Think bad. My jokes just that bad. Oh, good, she on the ground rolling.
She went on the floor again.
Ah, hypish laugh.
No, it's just slow.
Yeah, she wasn't feeling well.
Oh,
Sorry. Cheesy words.
oh God.
She don't cry when she saw the food today, don't she?
Yeah, most likely. Or like salad for something. Here, look, a leaf of spinach. Have grass outside in the yard. Some must.
Like kale.
Have some. Your kale's good on real good. All right, cool. Let's finish off this real quick because yeah, I want to take a look at least one circle geometry question because it's perilously close to that time of night, guys. Perilously close.
Oh, we have to do this and that.
So-
I just squeeze in like one thing.
One or two circle geometry questions somehow.
We have like
N inverse. How do we find n inverse now? Where's n?
12.
80 minus
4, 1, 3, 2. So this is n. So to find n inverse, we have to do 1 over the determinant of n multiplied by n adjoint. Right, so that's 1 over. How you find determinant again? Right, multiply the elements on the lead diagonal and subtract the elements on the product of the elements on the secondary diagonal. Sorry. 4 by 2 is 8, 1 by 3 is 3, therefore you get 5. And the adjoint, you swap out the elements on the lead diagonal and you just simply swap the sign. So we have 1/5 by 2 minus 1 minus 3, 4.
Okay, so I'm ready for matrices.
You ready to go? Yeah.
Ready
Alright,
for
cool.
matrices, ready for vectors, circle geometry is easy. Don't know anything about
What?
simultaneous, anything about completeness.
Do the simultaneous not last night. Check out the live.
Okay, I'll check
A
it out.
day like night. Right. Okay, now hence calculate the values of x and y for this. Okay. So we notice that these matrices are the same. Right? So this is n. This is x.
Minus 4.
Alright. Let's just call this b.
Okay, then go ahead.
Right? Now in order to solve this, very simply, we simply have to multiply the inverse on both sides of the equation. So n multiplied by nx, n inverse by nx is equal to n inverse by b. N inverse by n. What did we get just now in the previous question when you multiply the inverse by the matrix?
The infinity.
1, 0, 0, 1, which is the identity matrix, right?
Okay, now the infinity.
So I by the indent demand says get a shift to the right. Alright. And when you multiply the identity matrix by any compatible matrix,
You get what I see.
you get what you say, right? Multiplying by the identity matrix is the matrix equivalent of multiplying by 1. And when you multiply by 1, you get about the same number, right? So x is simply equal to n inverse by b, right? So now we will take n inverse and multiply by b. I think they say what is the effective word. So row by column.
No, if they ask me to come back,
Ah.
I can just sort pieces on.
Keyword if.
When?
When they say if, I don't know.
You know, I could be in black eyed peas and I watch.
I could be in red beans at upstairs. That would give me gas. Well, they wouldn't like that. They wouldn't like
They
that.
also in black. And we didn't want to
go ahead.
I feel like I got something wrong here.
Yeah.
Oh gosh, I don't know.
Nah, you're fine.
But it's not going to tie back though. Can you do simultaneous? You could, yeah, but they made it
That's
to be near. Yeah, you could do the simultaneous, but they already had their calculated the inverse in the previous question. So my thing is you just had to use the inverse. Okay, what's 2 minus 2? That's 0, right?
Yeah.
But minus 3 plus 8 is 5. Okay, so we have 1/5, 0, 5. 1/5 of 0 is just 0. 1/5 of 5 is 1. Therefore, x is 0 and y equal to 1.
That's it.
Yeah, now look. Yeah, this one. I know for some reason I see minus 3 plus like 11. No, that's added. Wait, hold on. Right. So that's the matrices. We have 7 minutes to do circle geometry. You do that one? Look, hold on.
Look at how hard it is.
Chris,
Look here.
Chris.
Yo.
So just 7 minutes. I'm gonna go through an activity for example, and we'll want to go.
No. Let us just go through on it.
Oh, I shut up.
No, that's what you're saying. You're saying go through it on the board. And when you go home, you can rewatch.
Oh, well, I don't know.
Alright, I'm just gonna do one question, and if we have time, a second.
Yeah.
Oh, wait, yes.
Oh, you don't catch what you said?
Yeah.
Alright, cool.
Yeah, but
Well, here, we'll push it to about 8:35. If anybody had to go 8:30, you could go, it's not a problem. I'm not chaining it down.
I can shoot.
Alright, cool.
Nobody want
A circle geometry? Alright.
I did this question.
Nice. Alright, folks. Can I shift from this pair so people copy nonsense off? Can shift? Yeah? Alright, cool. Time for that. Anybody got time? Anybody got time? Anybody got time for that? What about time?
I'm not sending it to you alone, so yes, you will get it.
Alright, we on the board? We like a notice, we on the board. Right, cool. So, the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference.
T is 75.
Right. QRS is a straight line. QRS. PVR is 75 degrees. And this is 60 degrees on that side there. Determine the value of each of the following angles, showing detailed working when necessary and giving a reason to support your answer.
Angles of the same arc.
Right, correct. So, this angle here is 75 degrees. Basically, anybody watching, let's imagine this wasn't here, and that wasn't there, and that wasn't there. You have to learn to unsee what is there. I know that might not sound like it's making sense, but block it out. Put fingers to block out pieces. Right? I call this the butterfly rule, or the Deadpool rule, or the Spider-Man rule. It's not like a Spider-Man piece from the comics. Right? Kinda. Anyhow, whatever. Right? And the angles up in the corner, once all of those vertices touching the circumference, right? P, V, T, and R, once they're touching the circumference, the angles up in the corner is equal, which means that these angles here, down here, are equal to each other. Yeah, angles in the same segment standing on the same arc are equal to each other. Yeah. Uh-huh. Right. You think it's parallel? Right. The only way it's parallel is if they give you the arrows on the line. That is how you know they're parallel. Don't ever assume they're parallel unless they tell you explicitly in the question or unless you see the arrows. Alright, cool. Correct. Correct. So these angles here are equal because they are angles in the same segment standing on the same arc. And those the vertices of the shape must touch the circumference. That's correct.
Oh, that's nice.
Where?
What do you call the one?
Sorry, 1 second. Hello? Oh, okay, I'll take that up when I come out. Thank you. Good luck in maths tomorrow. Hey, Zalia, good luck to you too. Alright, TPQ. TPQ, right, starts at T, goes to P and ends up at Q. So that's this angle here. Right, this angle here.
I got 180 minus 79 because I was just like,
I got.
Right, now check this. Right? If we ignore this line and this line, right, let me highlight what's left. What is it?
Hey, what's that?
60 degrees.
Right. All you see in the yellow lines? How many yellow sides I have there? What do you call a four-sided shape? A quadrilateral. And then what the where was circle geometry gone? Right. And in this case, this quadrilateral is inside of a circle, and all of the vertices T, P, Q, and R touching the circumference. This is called a cyclic quadrilateral. And the rule with a cyclic quadrilateral is either the opposite angles are supplementary. In other words, they add up to 180. So this would be 105 here because that's 75. But the other rule is that an interior angle could be equal to the opposite exterior. So that's 60 degrees here. Right? So like I was telling, sometimes you have to learn to unsee the lines that are there. It's not an easy thing to do, especially if you're not practiced doing it.
So we can use on
the angle, alright.
the exterior opposite.
Right.
Yes.
The angle in the cyclic quadrilateral is equal to the exterior angle, the opposite exterior angle. Yes. Right?
Wait, because what if I did 180? I didn't do it. I knew it was 60.
Yeah.
But if I did 180 minus
Right.
60,
You could do that. You could
and
because
then just take it away from 80 again.
correct.
That's 60?
Correct. Right? What's that?
I go cycling.
Cyclic CYCLIC, and then quadrilateral is quadrilateral. Opposite angles are supplementary. The opposite angles add up to 180, and the exterior angle is equal to the opposite interior angle. Because, like Jono was saying, no, it was Craig. It was you. You were saying that who was telling me to get 120 inside here? Right, that's 120 because this is a straight line, and the angle
is
equal to the opposite interior. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle.
Oh, it's not like opposite.
Hey Annika, what's going on?
Roshan, what you did 120 minus 80.
No, you find whatever that next angle is. If you just 180, 60, and then you have to use it by 180.
For the 60 degrees?
Yeah.
The external angle of a cyclic quadrilateral is equal to the opposite internal angle. Correct. You could get 120 here. Right? You could get 120 here.
Yeah.
Right? And then the opposite angles are supplementary. They add up to 180.
Okay.
Obtuse angle.
Hold on, before I erase the other lines here, everybody okay with that one?
Yeah.
Alright, erasing this information.
I low-key feel it.
Yeah, like.
Low-key feel it already.
This is the game. Well, I'm glad they put it. We now going to touch on it, girl. We have like 2 minutes again. So, just follow on where you can.
Technically.
Obtuse angle, POR, where O is the center of the circle. So, the PO is here. And that is the angle, POR. So, they want that.
Is it not
90 degrees.
Again, because it's a
Where you get 105?
It's not a cycle because it didn't touch the bad part.
No.
It touched
Alright. Hold on. Watch me here.
90 degrees.
Watch me here. Right, cool.
Alright.
You see. Right. If we ignore all them angles, right?
Baseball bat here.
We basically the baseball diamond. And the rule with the baseball diamond is that the angle at the center of the circle is 2 times the angle at the circumference.
Roshan, how are you good at this?
Wait, I didn't say that. Easy one.
The angle at the center, hold on, if this angle here is x, this angle here is 2x.
And then you could take it
1 second, Adela, let me get to you. I believe it's that, but let me get to you, right? Angle, right, twice the angle touching circumference, that's correct. But, hold on, let me put the working down, right? Okay, so check this. Jesus balls. Why? No. Right, you mean this angle here, 105? Right. Okay, so check it. What the brethren is saying is that if we ignore everything here, right? You come back with our next cyclic quadrilateral. Right? 1, 2, 3, 4. And these angles are supplementary here. Hold on. So there's 105 here, right? Actually, yeah, I now see what Adela was saying. That's correct. Which year is this? This is Jan 2019, Selena. Jan 2019. And it's question 9 part A. Yeah, thanks Mia. Right, so you get the 105 there. Yeah. So when you get 105 here. No, hold on. That means that this angle here is 210.
Yeah.
And therefore the angle on the inside is 150.
You gotta take it from 3.
Correct. Right? Because this angle here is double that angle.
So you would put it off for the reason is because
Well, actually, one of the girls in the chat now saying that an easier way to do it is if you ignore these things here, right? That this here is the same angle at the center, is double the angle of circumference. She's saying here it's just 2 by 75.
oh gosh.
I'm not seeing it. Hold on. The book doesn't show you that one, but I've seen it. I have seen it in an example in a book, so I know where she's coming from.
Well, that isn't like the angle.
Yeah.
I don't think I would see that in that test.
Wait, so we have to find
Yeah.
this inside angle here.
Yeah.
But that's not interesting.
Yeah, 150 is correct.
Yes. Let's go. What? So I did 360 minus 105 by 2.
Right, that's correct.
360 minus
let's go.
105 by 2.
I got this too, bro.
Alright, guys. Alright, Shema, you're jumping. We're almost done.
I got 210.
So hopefully you could remember 210 is on the outside,
Yeah.
right? So this is 210 here, right? But they want the one on the inside here
So you minus it
from
from
360. That's correct. Alright.
105 by 2.
Hashtag ready.
Alright. Scrolling down. Sorry.
This next one's hard.
The next one, this
No,
is
it's
the
not. It's not.
May 2018
What if this is
diagram is not drawn to scale. Shows a circle, center O. Points A, B, and C, and M on the circumference. Straight line CN is a tangent to a circle at point C, and is perpendicular to BN.
Wait, what if you call the line a triangle form on a diameter is the 90 degrees?
The angle form here is 90. So the first thing they want is angle ABC. ABC is right here. Now, once again, if you ignore this business here and this business here and everything, and if you ignore all that, you just have a triangle, right? And that triangle is built on a diameter. A diameter cuts a circle in half. Half a circle is called a semicircle, and the angle in the semicircle is 90 degrees. Right? So this is 90 degrees here. Right. Remember you want this angle here.
Yeah.
And the sum of
180 minus 90 plus 50.
correct. So this is 180 minus 90 plus 58.
42.
Correct.
No, I was just looking at it like that. Just to make sure it's 90, just look at the 180 the outside would be
Okay. Alright. Yes. Oh, 32? 32. Yeah, because 90 and 50 is 148. 180 minus 48 is 32. That's correct. Alright. Next one they want is CMB. So I'm going to erase my annotations. Right, so CMB is that angle there.
It's supplementary. Or
Correct.
Yeah,
If you ignore this angle, this line here, as a cyclic quadrilateral.
Yes, the answer is actually 30. Oh, you put it
Yeah, and the opposite angles of a cyclic quadrilateral are supplementary. Right, so that would be 180 minus 58, sorry. So you have 122. Right, opposite angles of a cyclic quad are supplementary. And NCM, so let's take off some stuff here. Right, so NCM is this angle right here. Alright. So good, what's that one again, boy? That one, oh no, that one is, hold on, wait a minute. That's not the angle between tangent and chord, it's equal to the angle of the alternate segment. Right.
Between segment and chord?
Tangent and chord is equal to angle in the alternate segment. Alternatively, we have a much easier way to find that. Didn't we just find CMB as 122?
Yeah, so then you take it from,
Look,
you take
right.
it from 180. and-
Correct. You can get this angle, right? That's the 58 degrees, and you add those two, and you minus from 180, and you get back the same. What?
Okay, but what did you use for your narration there?
angle between tangent and chord.
What did you use for your narration for that? Because I wouldn't have a narration for that.
Yeah, 180 minus the 90 degrees.
Minus 180.
Yeah, plus the 58.
I just put that straight line as equal to
Wait, we can't do the angle of the alternate segment.
But we don't have this angle.
Yeah, that's what I said.
And it will
Yeah,
be hell to find it.
The easier way to do it is just, yes, to do it this way. 90 and 50, same 148, so that's the same 32 degrees.
And the reason is.
Well, first of all, the angle on a straight line is 180 degrees,
Okay.
and that's how we get the 58. And then the sum of the angles in a triangle is 180.
Because I know you want to do the next one, you know. I know you want to do.
I do.
I know you want to.
Right. Sorry. The folks online asked me to repeat that one. Okay, cool. NCM is this angle here, right? This piece here. That's in a small triangle. Now we just found CMB. CMB was 122. We have a 90-degree angle here. So if we were to find this angle here, we could just add that to the 90 and subtract it from 180. Right? The rule with the tangent. Alright, just now. Come back to that one just now, right? So if we take 180 and minus the 90 plus 58, we got 50 because we minus 180 from 120 from 180. That's 148, so that will give us 32 degrees, which is the same angle here. I mean, those angles are equal. That's an interesting one. Alright, subtract it. Yes, then subtract it from 180. Yeah. Alright. Oh, and that other one, who's Adela? Right. This is a tangent, right? This is a chord, and there's a rule that says the angle between tangent and chord is equal to the angle in the alternate segment. Right? That one, yeah, you could YouTube that one after. They could show you that one. Sorry, I can't go. I'm actually 10 minutes behind my time now. It's two things. The sum of the angles in a triangle is 180, and then the angle on a straight line is 180 degrees as well. Alternate segment, yes, yeah, that one is a bad one. It's a bad one. That next, oh good. Just people outside. See if they have any cars coming on. Must have at least 2-3 cars outside.
I'm on here, so.
Yeah.
Alright. Most likely, yeah, they always have you on time. Alright, short boy. Alright, guys on the live, give me 2 minutes. I see some more students out. I shall return. Rihanna in your class was the person who introduced your life. Thanks so much for this service, very helpful. Thanks, Rihanna, very much. One of your friends, Aliyah, saying you introduced her to the live. Thanks very much. Annika saying hi, Brian. So what time you going up to? Next 10 minutes. I just see my students out, but I'll come and finish off a couple of questions again, right? Just give me 2-3 minutes, right?
All of it.
Folks, it was a pleasure.
Yes, it does.
Thank you for being here. Right? Hope the exam comes well.
Chris, why are you thanking us to be here?
You should be thanking you, brother.
Well, it takes 2 hands to clap for this event, so.
Whoop, that's what we're talking about.
Yeah, everybody. Alright, good night. Sorry.
Only once.
You want to go walk?
Only once.
That's what
Only one G.
Brian, they're here for you.
Only one G.
Later, guys. See you all.
Okay, they're across the road for you too.
You know they said I don't think it's a percentage. I asked her, so if I get 20 out of 20, she said I got 20 out of 20. How much would I go to?
Alright,
She said,
okay, good. Alright, yeah. Alright, guys, on the level, come back. Just give me 2 minutes. I just see my students out. I'll return. I'll finish at least 1 or 2 more questions with you on the live, right?
that's a one.
I didn't forget about all that. Coming back just now.
Damn.
Sorry, stay for those 2 questions.
Alright, no problem.
I might correct that's why my hand is
Dark colored cows, I'm not sure.
What do you want?
I have to call my mom to come.
Yeah, you want to call it.
Oh gosh, well I guess it's me alone now.
Yeah, I'll message in the group about the PUB and the econ, right?
Okay, yeah. What group?
I have your, no, it's not a group, I have it on a broadcast list.
Oh, okay. See, thank you, Chris.
Good luck tomorrow.
What do you want? What do you want?
Yeah.
Cool.
Alright, thank you very much, man. Hey, man. Keep good.
I'll tell you, I know the Lord, yeah. What's up? You think the Lord?
Yeah.
Blessings. I'll call my mom.
Who's this guy? That's Liam? Alright, bye-bye.
We'll come one time.
Yeah. So by the time you reach,
Yeah.
we'll be alright.
Alright, we're going. Back on the line. Chris, message me too now. Message you too? Okay.
Say she'll send me the completing the square thing, but I'll still get it from you too.
Yeah, I did. Oh, Annika, you're talking about the PUB and the econ. I do have your number, Dread. I'll email you, right? Or I know Chelsea in the group. Sorry, it's not a group. It's a broadcast I have. Chelsea and both the PUB and the maths. So just liaise with Chelsea, right? Okay, guys. We just did the May 2018. So we're looking to do Jan 2018 and possibly May 2017. Here, let's just start and we go into the come for Antonio. Right? Okay, so let's go. Come now, man, Philip. Do that. Alright, you ready?
Yeah.
Alright. Diagram below, not drawn to scale. Circle, center O. It's always important to identify the center they give it to you. Alright. The points A, B, C, and D on the circumference. Okay, so we have a cyclic quadrilateral. Let's just point out one time, right? Why are you scrolling up? Behave yourself. One note, you're giving trouble. You're giving trouble this Saturday night. Men have things to do. Exam is tomorrow. So we have a cyclic quadrilateral. Right? EAF. Right? EAF and EAG are tangents. And touch the circle at A and D respectively. So we know something about that. AOD is 114 as in the center of the circle. CDG is 18 degrees. CDG is here. Right? That's this angle here. Calculate giving reasons for each step of your answer the measure of ACD. Alright, so once again, ACD is this angle here. What we're going to do is once again eliminate and disregard all of the irrelevant portions of the diagram. Right? And we're just going to focus on that. So that is the rule where the angle at the center is double the angle at the circumference. Right? So angle ACD is equal to, so if the angle at the center is double that, this angle is half of that. So that's 57. Right? I'm not going to write out the rules because we tight for time. Adela 33. Nah, Adela is 57. Right? So you're seeing this one, this angle at the center. You only want to tell me just now that angle at center is double angle at circumference, right? So this is one of those variations on that particular shape, that diagram as well. That's right. Or maybe you're answering a different question. I don't know. You're answering this on 8:45. What? But we live and direct and in time. ACD. All right. So I hope I cleared that up. Angle C. Yeah, this angle here. This angle here. That's 57. Most I've ever learned in an entire math. Okay, Andrew, I'm glad to hear that. Angle C is 33. Why is 33? What's the rule? What's the logic? Angle C. Which angle C? Nah, I can't. I can't agree with that. If you could give me a reason, I'll consider it. But from what I could see here, angle C is 57 because that's the angle of the Oh, you see it? All right, cool. All right. Sorry, I wasn't trying to. Oh, you make any position. Oh, yes. Be careful with that. Right? I didn't mean to sound like I was buffing you out or anything. I just kind of in a hurry. I'm real sorry about that. All right. AED. So AED.
All right. Okay, just give me a minute. Sorry, I have to message. I have to respond to a message. Okay, cool.
Yeah.
All right. Sorry, guys. Oh, you had to roll one time?
Yeah.
All right, cool. Okay, guys, sorry. Let me just see Antonio too. I will go up to 9 o'clock with you all. All right, just give me 2 minutes. Let me just see Antonio out, and I will go up to 9 with you all.
I'll message you when I reach home. Sorry, my name.
What's that? Oh, right, guys. Go through. That's all right.
Oh my goodness.
All right, Antonio.
Thanks a lot.
Okay, no problem. My pleasure. If you're going through any multiple DMCQ on your final error,
I'll make sure
yeah, you'll never know.
Thanks a lot. My mom wanted to know how much the tally is, so
I'll message everybody.
alright, now.
Cool, man. Later. Woo! Wow. Yeah, guys, sorry about that. One of my students was leaving again, so I had to see him out. Inequalities, rotation, reflection. Andrew boy, I hear for the next 11 and a half minutes. I'm real sorry. Well, I had to go. Like I said, up since 5. I started work about 6, 7 o'clock. So I kind of running on fumes here. Right? Anybody else kill Samuel? Ariella? You kill somebody? Okay, that's not my business. Sorry. Going back to circle geometry. And how more than one person, sorry, again sidetrack, right? ACD, we get ACD, AED. Now that's this angle here. Alright? So, what we'll do is we'll scratch out all of the irrelevant pieces of the diagram. The diagram. Right. We could leave that, we could leave this too. That also. So what we're focusing on really is the 2 radii and the center of the circle, 114. Now the thing is, those points there are where tangents meet the radius. Sorry, my bad. Right, this is a radius here, there's a tangent here. And the angle between tangent and radius is 90 degrees. Right, so the thing is, this is a 4-sided shape, a quadrilateral. Oh, Chris, it was English. Oh, sorry. Samuel Horn, woman Horn, he, oh Lord, sorry, again sidetrack. This conversation in the live going interesting. Sorry, so you have 2 90-degree angles which will add to 180. Which means these 2 angles also have to add to 180. So 180 degrees minus the 114 will give us 66. Erase no man, embarrassing money life. Right. Good. Nadino boy, you almost get blocked from the chat because of that phrase you have there, boy. Wow. Alright. All that. Real interpretations. Right, so it's 66 degrees. Right, multiple reasons went into that, but like I said, I don't have time to go through all the reasons right now, or to write them down. I just kind of doing it on the fly here. Because man has to go. I gotta go super farm and buy stuff to the people lecturing. Right, OAC. Now, OAC, let me zoom into this. OAC is this little piece of angle right here. That little piece of thing right here. And to find that, now we have some stuff to help us. Once again, let's eliminate all of the irrelevant information from graph, right? Let's get rid of that. Okay, so first things first, I want you all to acknowledge that this line, which is OA and OD, are both radii. Matter of fact, I'm going to highlight those lines. OA and OD are both radii. And what do we know about all the radii in a circle? They're all the same length, which means that any triangle built on two radii must be isosceles. Right? So therefore, these two angles, sorry, I don't want to put blue, I want to put orange again. Go orange. These two angles down here will be equal. Right? So if we take 180 and minus 114, if I teach econ, Adam, I don't teach econ per se, but I did econ for form 5 and form 6, and I do little, like, I don't want to call them crash courses. My students come a couple days before the exam and we go through a bunch of past papers. I will probably live stream those as well. What I will do is, if I'm doing them, I will put up a message, a story on Instagram. So if you're not following me on Instagram, look for Adapt Tuition. All right, I might be a bit rusty in certain aspects, but the students I have are pretty bright, so we feed off of each other's information. Right, I do know how to answer questions and help with the structure and that kind of stuff of answers. And the multiple choice, most of the times I get most of those things correct. And I have one of my mom's cousins has been teaching econ for the past 20-something, 30-something years in CIC. So if I have any questions, I just give him a call. All right, right. Sorry. So if we now divide that by 2, we get that each of those orange angles is 33 degrees. On top of which, let me get my pink. Right? Class and location, here what to do, message me privately on Instagram now, and we'll discuss that. Alright? I'm in Diego Martin. I don't know which part you are, but if you're close to that, we could discuss that, right? Okay. So this angle here is 18 degrees. And that angle is between a tangent and a chord. And that is equal to the angle in the alternate segment. So this angle here is actually 18 degrees. Right? That's one of the Mr. Balwan. Yes, that's my mom's cousin. Yeah, he actually I went by him for a couple of econ sessions back in 2000 when I was doing form 6. Right? It's pretty good. Anyhow, so like I was saying, to find the remaining piece of that angle now, which I will, let's just color it in green, shall we? This green piece right here. Alright, this piece here. We simply have to find the difference between those two values. I was right, alternates. Alright, cool, let me see. So 33 minus the 18 will give us 15 degrees. I'm not sure which alternate you're talking about there, boy Nadino. But I mean, if you know a rule that I don't know, that's cool. I don't know everything, right? And I'm very curious to know what I don't know. and I know that sounds kind of weird, but I hope you understand what I'm saying. Anyhow, as OAC, and we could do ABC very quickly. So that's equal to 15 degrees. And then the last one was ABC. Right, I need to take off all of this excess notation in the diagram so we can see things more clearly. ABC is this angle up here. Now, we have a cyclic quadrilateral. Let me get a highlighter going. 1, 2, 3, 4. Which means, therefore, that the opposite angles are supplementary. So this angle and this angle add up to 180. Now, if we could find that angle, that would be very helpful. Can we? I believe we can, because this line is a tangent. This line is a radius. And the angle between radius and tangent is 90 degrees. Well, you see, that carries all out here. Alright? So what are we going to do there, boy? Now, the thing is, we do know something. We know that this is 33 degrees here, which means we just had to find this piece. And like I said, tangent and radius, which means 90 degrees here. And if the outside portion here is 18, to find a piece inside, that's just 90 minus 18, which will give us 72. Right? And guess what? 72 plus 33 would give us 105. And once again, the opposite angles of a cyclic quadrilateral are supplementary. And 180 minus 105 is 75 degrees. Alright guys. That was the Jan 2018. I think I could squeeze out one more for you all before I had to call it quits. Let me see. You know what? I have two more. Anybody? Angle in the smaller section is equal to the angle in the larger section, alternate circle theorem. I know what that one is. No, I had to see a diagram of that one, but you know. Angle in the smaller section is equal to the angle in the larger section, alternate circle theorem. That's the one you're talking about? Hold on, I know. I'll take a screenshot of that actually. Right, I'll screenshot that. I go and research that tomorrow because that might be something good to know going forward, right? Opposite. Okay, alright. Actually, I had to screenshot that too. Now that you give me some more context. Alright. Opposite C. Alright, I understand. Don't worry about it. Alright, guys, very quickly. I had to go through a couple more questions here for you all because I want you all to be prepared for tomorrow. Alright. P, Q, R, and S are 4 points on the circumference of a circle. How did you get the 18 degrees? Oh, the 18. Right. That was what I thought you were using. Well, they give us, remember, this angle, right? This angle here, that's 18 degrees there. My head hurts. Yeah, sorry, Ariel. I know, yeah. This could be, I'm trying to do plenty in a short space of time, and I'm sure it's not overly comfortable for some of y'all, so I do apologize. Right, I'm sorry to rush, but I do have a bit of a time constraint. Right? But I'm hoping you're absorbing something. And I'm sorry all of this scene is the bloody roof break. I really wanted to, I was trying to get I paid 20 freaking US for an app to turn my phone into my webcam. And then when I tried to stream it to the OBS, the Streamlabs OBS software, it wasn't even picking it up. So I spent 20 US today and it didn't really have any benefit right away. But I'm going to make it have benefit eventually. Alright, sorry, all I need to know all of that. That's not relevant to all your life. Okay, right. Geometrical properties of a circle give reasons for each step. So SPQ is here. If you ignore everything in the center of the circle there, what you have? Opposite angles of a cyclic quadrilateral. So SPQ is equal to 180 minus 58 degrees. That's 122 degrees. Next, the next angle they want is OQS. So let me erase the business here. So OQS is this angle right here. Now, O is what? The center of the circle, which makes OS and OQ radii. And all radii are equal. So it means that this triangle in the center here is an isosceles triangle, sorry. And we can also see this rule here, I call it the Star Trek rule or the arrowhead rule. The angle at the center is double the angle at the circumference. 2 times, very good Adela, 58 by 2 is 116. So OQS would be equal to 180 minus 116 divided by 2. So that's 64 divided by 2, which is 32 degrees. Feel free to let me know if I made any mistakes. Right. Okay, it was only 2. I only have those 2 items for this question. Right, that is 9 o'clock, so I'm going on to my last question. If anybody has any questions on this item, please speak now or forever hold your peace. Who my stomach's on the growl on thing, boy. Okay, I don't know water. Alright, I'm in some trouble. I need some water. Got here in time for this, yes? Yes, Vanessa. Just in time, but is the last question I'm going to know. You can watch it live when it upload. Alright, last question. Jan 2017 for those who want to know. Diagram below, not drawn the scale, center circle O. This is the center of the circle. But it doesn't look that way, but you have plenty of things crowding the diagram. Actually, anyhow, vertices H, J, K, and L of a quadrilateral lie on the circumference of a circle. PKM is a tangent to the circle. PKM is a tangent. Right? You have your cyclic quadrilateral. Alright. You have 20 degrees and 50 degrees here. Okay. Oh, good. Ariella blazing, boy. HKL. Alright, so HKL is this angle here. Alright, how you get 32? If you scratch out this, you scratch out this, you scratch out this, right? We see in the kind of butterfly thing, right? The kind of hourglass, the kind of X kind of thing. And the angles in the same segment are equal. So I believe HKL should be equal to 20 degrees. 160. Which angle are you talking about? GOK? 160. Nah. Hard luck. 20 degrees. Alright, angles in the same segment are equal. You see it, right? Once you've seen it, that's the important part. Alright, I erasing these extra notation thingies here, right? So HKL 20 degrees, right? And the 20 degrees, right? That's because angles in the same segment standing on the same arc are equal. And the last question before I left all here is JOK. Don't make joke. Sorry. So JOK is right here. O is the center of the circle, which makes OJ and OK radii. All radii are equal in length, which therefore means that it's an isosceles triangle. And this angle is 50 degrees as well. And the sum of the angles in a triangle is 180 degrees. And if we subtract the sum of the other two angles, right? We subtract 100, we get 80 degrees. Jaden, hey, Mr. Lewis. Hello, good night, sir. It's good to see you on the live. All right. Ladies and gentlemen, it was a pleasure to have served you tonight. I hope I met your expectations and I provided some value. I would like to wish each and every one of you good luck and good night. And please remember that no one exam or no series of exams determines your worth as a person. You and your actions determine your worth. Alright? Whether or not you get all your ones, all your passes or whatever, what you do next is up to you. Yes, you may have some challenges, no matter if you get all your passes and all your ones. You may have more if you don't do that well. You are in control of your decisions and your destiny. It may not seem so sometimes, but please know that you matter, right? Your grades, yes, they matter, but they don't matter more than you. Don't let anybody treat you based on what your grades are. You are more than your grades. Alright? I feel very strongly about that. Okay? No matter what grades you get, you can know if you don't get good ones, you can go back and repeat in January. You could learn other things. You could become more computer literate. You could become a social media genius. You could be a very great artist. You could be very skilled in music, whatever it is. But you need to have a job to be able to pay your bills and eat, right? So yes, you need to have some formal education to get a good job, right? But at the end of the day, don't let anyone treat you how they feel you should be treated because you don't have good grades or whatever the case is. Anyhow, I started to ramble and I'm not too coherent. Right? Please pray for us again. Alright, I don't mind praying again. Heavenly Father, thank you once again for another day of life. Thank you for health. Thank you for home. Thank you for family. Thank you for those who love us. Thank you for this opportunity to sit this exam, to have worked. Thank you for the opportunity to work. The most important thing is not the end result, although they make us think that is the case. It is the process. It is what we go through. It is all the sacrifices, all the hardships, the mistakes that we make, and all the lessons we learn from them. Please help us to have a spirit of calm in the exam and to practice proper exam technique. We ask you for your wisdom and your grace, your patience, and we trust in you. We trust that you will guide us through whatever it is will come our way. We make this prayer through Christ our Lord. Amen. All right. Okay, Jermaine Hatton. Jermaine, Mr. Hatton, sir, good night. Thank you for joining me live. It's a pleasure to have you here. I've heard good things. Sorry I didn't get to check out one of your live streams as well. I hear you do great things. All right. Anyhow, ladies and gentlemen, it was a pleasure once again. I wish you all good luck in whatever it is you choose to do. And I'm trying to move the screen. No, sorry. Right. I wish you good luck in whatever it is you choose to do. And remember, if what you're doing is not working, you have to change your approach. You have to try a different approach to it. Right? You have to adapt what you're doing. Okay? Good night.